Ave Coders, and welcome to this fast-paced ultimate Python course for beginners. But I've put together all Python lessons for beginners that I was carefully hoarding on my channel. We'll start by learning Python from scratch in an entertaining, no time waste manner. Then we'll proceed to the basics of OOP, or object-oriented programming in Python. We'll also get ourselves familiar with data classes, magic methods, and enumerators. We'll dive into the basics of testing your code and also how to interact with databases, and of course how to write code properly by observing the so-called Python Zen. And we'll finalize our journey by solving some popular coding challenges. And when you'll be ready to continue training, you should check the links in the description under the video, which I've left for you. I wish you good luck and persistence. Let's begin. First of all, I assume you have no Python installed on your machine, so we head to the official Python website and we download the Python. You might have a different version as the time passes, and please make sure you tick the Add Python to the Path tick box and you click on Install Now. So it is not a rocket science because it literally takes a couple of minutes to install, and then we need to check the version. For that we type in Python version. Again, mine is 3.8.6, yours might be different. And here we have the installed packages. One of the application is the Python shell, where it works as a REPL, where we can just literally type in something and get the response immediately. But of course we want a proper IDE for this masterclass, so we're going to head to the official PyCharm website where we can download a community version. So we tap on download button and we are headed to the next community version download step. So we don't need all that, and because it's going to be another Windows install, all we need to do is just click next and put ticks in the right boxes. So next, and here I'm going to tick the create desktop shortcut and add launcher to the path. I also want it to be a default opener for the .py files, and then click next and install. So that works pretty quick, and that is it. Of course I want to reboot later. Okay, so we have PyCharm and Python and we're ready to crack on. So the first launch is going to offer the theme light or dark. I'm going to choose the light one, although you might choose the dark one if you prefer to work at nights. So I'm gonna continue with the light theme. Alright, so now I'm gonna start the new project, and I think I will leave the name as default Python project. It's pretty good for a tutorial. What I'm gonna do, I'm gonna change the location to something like tutorial Python-ish. Let me get something that comes first into my head. Tutorial. Yeah, that should be enough. I click create, and it's starting our project, launching the environment, and some tips. And now we are pretty much done. We're ready to begin. We are in main.py and we're going to begin with what primitive data types do we have in Python. So we have ints, as known as the whole numbers, such as 1, 1, 2, 3, and even 0. although this is a disputable one. We also have strings shortened to str, and we write them in between the quotes, single quotes or double quotes. These are the examples. Even the number written inside the quotes will be treated as a string. The next data type is Boolean, which is true or false, on and off, 1 and 0, and so on. The next one is, of course, float. These are the numbers with the decimal point, such as 0.1, 6.9, and so you've got the idea. So now that we know that we have them, we can do something with them. So I'll leave them here just for the reference. Unlike in strictly type languages where we have to specify the type of the variable, in Python we can write just the variable, and in most cases Python will be able to assign a type implicitly. So let's say we have a channel variable. Say in Java we would have to write string in front of it, but not in Python. Here we can just leave it as it is, and because of the value assigned to it, Python will understand what kind of a type it is. So to run this code, I will get rid of our references and I'll run it, and I highly recommend you to learn the shortcut keys to run or save or do other stuff. But for now, I'll show you how to run it in the old way. So it has printed out the Ave Coder, the value of the channel variable, which is of a type string. So let's say further down I decided to change the value of channel to hello world and print it out again. And so Python will read the code line by line and will print out hello world and Ave Coder as well. Nevertheless, they are two different values assigned to the same variable in the same program. Now let's say we have variable h, we assigned an integer value of 25 and we decide to print it out, and here we go. Let's observe the behavior of the Boolean type. So I'm going to create a variable called isItTrue, and I will assign a value of true to it. And then I'm going to print the isItTrue as well, and so we can see the result. So Python has assigned the value implicitly. Next is a float. So bottle will be of type float, 0.5, and I'm going to print it out as well. So I'll run the program now, and I'm going to get another value of type float. All right, so let's move on. You will be surprised, but we already have some knowledge that will allow us to write a simple program in Python. Say we want to ask user for a name, and we can do that. We're going to print what is your name, and then on the next line we're going to create a variable called username, and we're going to assign the value from the user's input. To do that, we are using a function called input, and we print the value of that variable username. So it's prompting us what is your name, and we're going to type v, and it prints out our name. Not really useful, but still. So we can modify it slightly to add some interactivity. Let's say we want to greet the user. Therefore, we put Ave in front of it with single quotes. And now it greets us. However, there is no space between them, but that's not important for now. This was just an example. Let's move on to the operations. As you might remember from the primary school, we have the equal sign, the plus, the minus, the division, the multiplication, and so on and so forth. And as you might have guessed by now, we can use them in Python.
let's say we have a variable called number1 and we assign a value of 2. And we have a number 2, and confusingly enough, we're going to assign a value of 10. So we have 2 integers, and now we can do some operations with them. So let's say we're going to print out the summation of number 1 and number 2. So number 1 plus number 2, and we're going to print out the result of multiplication as well, and as well as division, and we're going to probably need to reverse them so that we won't get the negative numbers. So number 2 minus number 1, and same with the division, number 2 divide by number 1. And let's run it, and as you can see, we get the results. A couple of other operators worth mentioning are the exponent, which is this double star. So this performs exponential calculation on operators. So let's say we want to get number 1 to the power of number 2. Effectively, this is going to be 2 to the power of 10. And of course, we're going to print the result. This is 1024. So the next operator is called floor division. Effectively, what it does, it returns the result of the division without the remainder. So if we'll divide 2 by 10, we'll get a 0 because 10 is bigger than 2. But if we'll swap them around, let's say we divide 10 by 2, we'll get 5. It might not be a very good example because it doesn't have any remainder, and the effective result is the same as if we would use the simple division, but you've got the point. So the next operator is called modulus, and it works the opposite way. It returns only the remainder of the division. So when we divide 10 by 2, we do not get any remainder. But if we'll divide 10 by 3, you see that the result is equal to 1, which is indeed true. So let's put our new knowledge into use, and we're going to write a simple interactive program where we're going to prompt the user to give us the number, and we're going to do an operation with this number or with those numbers. And so we're going to ask for the first number, and instead of assigning a value to the number 1 explicitly, we're going to use the user's input. And we're going to print it once again, this time asking for the second number. And once again, the number 2 will be equal to the user's input. And if we'll leave everything as is, we'll run into a problem because Python treats user's input as a string. So effectively, we cannot perform mathematical operations with strings other than plus, which is concatenation, but we'll talk about it later. And as you can see, we have a type error, cannot multiply sequence but by non-int of type str. So what we'll need to do, we'll need to convert or cast user's input into a number, because otherwise, as you can see in the output, we had 4 and 7, and Python, because it was treating it as a string, it has concatenated 4 to 7, and we get 47 as the result. But multiplication with strings, there is no such thing. So as I've said, we'll need to cast the user's input into an integer and perform this operation again. To do that, we're going to just put int in front of the user's input and put user's input as an argument to the int. So the casting will be done when we'll type in the numbers. And as you can see, it has successfully performed all 4 operations without any troubles. So these were the main operators in Python. we can get rid of them and we can move on to the next topic. And this topic will be how to compare the values of the variables or the numbers. So greater than, less than, equals, or not equals, and we can easily illustrate that as 8 is greater than 4. So if we'll ask Python about that, it will return true, because indeed 8 is greater than 4. However, if we'll put it that way, it will return false, because 2 is less than 4. And they can help us later on in the simple decision making process. So this is the sign of equality, this is a sign of not equality. So a single equals is an assignment, a double equals is the equality. So that way it returns true, because 2 is not equal to 4. They are indeed different numbers. So if I'll print out, what shall I get? True. Let's give it a try with less than operator, and this should give us true as well. 4 is greater than 2. This will give us false, because 2 is less than 2. And this will give us false as well, because 2, as I've said, is not 4. However, we can combine them and we can get greater than or equal, or less than or equal. So we can write them this way. This means 2 is less than or equal to 4. And this will mean 2 is greater or equal to 4, which is false, of course. Okay, so let's give it a try, and we'll use them together with a simple decision making structures in Python. So we can put something like, if something is greater than something, do this, else do that. Or we can check for multiple conditions with elif, which stands for else if. I'll illustrate what I mean. Let's type a simple program. Let's say we have a number in mind and we want our user to guess it. So we're going to prompt the user to input a number. We type guess my number from 1 to 10. And we'll of course need to cast it to int. So we'll avoid the problems we had in the previous topic, so that we'll make sure what users type in will be definitely a number. And then we can start to construct our condition tree. If my number, this is what user puts in, if it is equal to 5, then we're gonna do a certain action. In this case, we're gonna print you are damn right. And then we're going to need another branch for those cases where user didn't guess the number correctly. So we're going to type else. This is for all other cases. If the number that user types in is not equal to 5, we print something like you are out. Let's give it a try. I'm going to type in, say, 4, and you're out. Okay, so this is something to begin with, and now we can expand it further. So let's say I want to add some more conditions, such as if my number is greater than 5 or less than 5, I want to inform user that you should try to guess another number which is going to be slightly bigger or slightly smaller. So we're going to modify our program. So I will expand my condition with elif. It stands for else if. And else if, or elif, my number is greater than 5. I'm gonna print out another statement which gonna point the user into the right direction. Let's say try less. Else, for any other cases, we're gonna say try bigger number. This should work. Let's make it correct. Try lesser number or whatever. Let's try and run it. And this is normally how you build the program. So you start with something really basic and then you expand on the functionality. So we're going to try 5. We're damn right. That's it. We need to run it again. 4. Try bigger number. Okay, 4 is less than 5. Let's try something bigger than 5. Try lesser number. And 6, try lesser number. Everything seems to be working. However, I don't like to restart the program every time I run it. And we'll address this later, but for now, let's move on and we'll add some more stuff to our program, which is another condition, and or not. So we can have multiple conditions in the same statement. For example, I can prompt a user for another number, or let's say that's not going to be the number, that's going to be a string, which is we're trying to guess a number and a color. So let's say my color, and we'll ask user, can you guess my color? And here we're going to say, is it blue, is it red, or is it black? So to make sure we narrow the search to those 3 colors. So now, instead of checking just one condition that the number is equal to 5, we're going to check another condition. So we put and my color is equal to, let's say, blue. And of course, we shouldn't forget that blue is a string, therefore it must be placed within the quotes. Now we need to give some tips to the user. Let's say if the number is equal to 5 and the color is equal to blue, we say you're done right. Otherwise, elif, my number is not equal to 5 or my color is equal to blue. So the main difference between and or is that in the case of and, both sides of the equation should be true, and in case of or, one of them can be true, one of them can be false. So I've also corrected that my color not equal to blue. So that should read if either of my conditions is not true, or we guessed incorrectly the color or the number, we will print out big different number and different color. Otherwise, we say else, print, try something else. So once again, this is just a simple bit of code just to illustrate how the conditions work in Python. So we have and, or, and we can also use not. Not has got the similar effect to the exclamation mark and then equal sign. So the logic is something like, if you are not hungry, don't buy a potato. But in this particular case, we can easily modify our code slightly with not. So let's say the elif condition, we can put not in front of the brackets, and then we can remove the exclamation marks, and still it will essentially mean the same. So now this code reads something like, if my number is equal to 5 and my color is equal to blue, you're damn right. And then if my number is not equal to 5 and the color is not equal to blue, you say pick different number and different color. In any other cases, it says try something else. But this is not the only way we can compose our program with these conditions, if and elif and else. We can also nest one condition into the other. For example, I can say if my number equals to 5, we're going to print you damn right, and then we can nest another condition which will check on the color. So to do that, I'll copy that line inside of our if statement. I'll get rid of those. And now I can say if my number is equals to 5, and again I can nest another if. So we're reading user's input and we're saving that input into the variable myColor, and then I can write if myColor is equal to blue. Then we'll print the same story. We're going to print you damn right. So I'll just copy it from there. I'll paste it here. And now I can get on with the elif statements. So after the nested if, on the same level, I will type else. So if I'm not getting my color right, I'm saying that number is right, but the color is wrong. So you need to pick another color. And then on the level where we checked the number, I will type elif. So if my number is something else than 5, say greater than 5, and here I will use the conjunction and to connect two conditions together. So basically I'm saying if my number is greater than 5 and less than or equal to 10, I will try to provide a user with a tip on which way to go. So in that case, I'm just saying pick a smaller number. And similarly, for the numbers that are less than 5 and greater than 0, I can put another condition, elif, my number is less than 5 and my number is greater than 0. I can say something like try a bigger number. So here we go. Elif, my number is less than 5 and my number is greater than 0. Print pick a bigger number. That way we can make sure that user is heading the right direction. And then of course else, saying in any other case we're gonna just print something like you are out of bounds. For example, if user will guess the number, let's say 15 or something like that, and don't forget to cast the user input into int, because Python by default will treat it as a string. So now our program looks neater and we have some sort of interaction going on. So basically we're guessing the number and we're guessing the color. So the guess for the color is nested inside the number guess. So we'll only let you in to guess the color if you have guessed the number. But of course this is something we can improve. We can give sort of tip to what color to pick or how many attempts, perhaps in the same way as we are providing a tip for the number. Or I might leave it as a homework for you because it's not too difficult to implement, and you will see why in a minute. And I should also mention that if you will enroll to some paid course, Python for Beginners, this is something that they will teach you and you will pay for this sort of knowledge. So enjoy this thing for free and never pay for the beginners course. All right, let's try to run our program. Prompts us guess my number from 1 to 10. I'll guess 3. Pick a bigger number. Try again. Because unfortunately the program doesn't give us multiple attempts, so we have to restart it every time we guess the number incorrectly. Let's try to guess the number correctly. So it prompts us what color do I have in mind. I'll put black, and now I have to restart the program again. Let's try 5 and say blue. You're damn right, that's the end of a program. So I guess now we can add a little bit more interactivity, and we can make sure that the program at least asks you to guess the color and the number a certain amount of times, so you can use the tips provided by the program correctly. And of course we can do that with a while loop. So while loop runs for as long as the condition stays true. So up here I can put while, and here I can specify the condition. While condition is true, we will do some stuff. But as soon as condition becomes false, we break from the loop. So up here I will declare a variable called loop, and I'll make it equal to false. Therefore, here I can say while loop is not equal to true. So as long as it stays false, we will do some action. And don't forget that we need to re-indent our code to make sure it is inside the while loop. So in here, if we guess the number correctly and we guess the color correctly, then we set loop to true. That way we'll break from the while loop. And logically that means that if we will guess something incorrectly, the loop will stay false. So let's test it. 4, pick a bigger number. 7, pick a smaller number. 5, we guessed it right. The color, black. Incorrect, and we're thrown out to the if condition for the number again. So we have to start from the top. So we guessed everything right, and we are finished. So from the start, there are 2 things we can correct here. We can make sure we're not thrown into the guess number condition every time we guess the color wrong, or we can also add some attempts. So if I'll declare a variable called count and I'll make the number of attempts equal to 3, I can limit the user to the 3 attempts. So literally I'll apply the same logic as I did with loop. So while loop is not equal to true, I can say something like while count is not equal to some condition, and I can say while count is not equal to 3, but I think it will be much cooler if we'll have count performing sort of a countdown stuff. So if I will put count more than 0, so I'll need to do the or. So if one condition is true or the other, and here I can say that count is equal to itself count minus 1. That will make sure we deducted 1 attempt from the count. And as soon as it will reach 0, so after 3 attempts, the condition that count is greater than 0 will not satisfy anymore, and we will break from the while loop. And I also think that it will be a good idea to add some sort of a countdown for the user to read. So we can say something like pick a smaller number, you have X amount of attempts left. So we have a string, pick a smaller number, you have then by using pluses we will concatenate integer count, and we'll concatenate another string to that count. And here is a little problem. The thing is, we have two strings, and if I'll hover over variable count, it tells me it is actually an integer. And if we'll try to run it as it is, we'll soon find out that Python does not agree with us concatenating string to the integer, and vice versa. So I'll launch the program, and as you can see, we get the error. Can only concatenate string to the string. But we already know how to deal with that problem. We can cast count to string. So it will read the value of the variable count and it will cast it to string. So Python, as you can see, treats it as a string. Right, so now we can do infinite amount of attempts until we'll actually guess it right. So it doesn't make any sense. So we need to correct that. Because at the moment the number of attempts decrease only if we guess it right, or in case we'll pick the number bigger than 5 and less than or equal 10. But we have a logical flow in our program. So in here, if we'll change OR to AND, so if two conditions will be satisfied simultaneously, we can see that it makes a bit more sense now. Because with OR, it was looking just for a single condition to satisfy, but now it works as it should. And we can repeat that for a number less than 5 or bigger than and bigger than 0. So now the number of attempts will decrease. So I'll change smaller to bigger. And we also might want to add the similar logic to the else statement. So it will read, you're out of bounds, you have X number of attempts. So let's try 4. Pick a bigger number, you have 2 tries left. Let's try bigger, 6. You have 1, 11, you're out of bounds. So pretty much it works as it should. But now let's concentrate on guessing the color and see if we can improve something there. So for every number I would guess now, I'll put 5 so that I can get into the nested condition, if else. So red, number is right, but pick another color and we are thrown out to the number guessing again. And if we put blue there, we will get an error. So this is something we can definitely improve. So two things we need to correct here. We need to make sure we're not thrown back into guessing the number every time we guess the color incorrectly. And we need to make sure we add counts to the color attempts as well. And I think in order to make this lesson a bit more interactive, I offer you this as a homework. Please put in the comments how you're getting on. But meantime, we'll move on to the next topic. And since we've already touched on the while loop, so now we know how it works. And next loop, we're gonna have a look at the for loop. So for loop is specified in Python with a keyword for. Then we declare a variable that will traverse in a certain range. So the range is from 0 to 10. And if now we'll print that variable, you'll see that it prints all numbers from 0 to 9 and excluding 10. So the first parameter inside the brackets is something called the start. So this is the point at which we start. And the second parameter is the stop point. So this is the condition at which we stop. And if I'll put another one, that will mean step. So quite easy to remember, start, stop, step. So we print all numbers from 0 to 100 and we iterate in step equal 4. So instead of 1, 2, 3, we're going to go 0, 4, 8, 12, 16 and so on. So once again, we can use something we know already, which is a count. We'll set up to 0 and we'll use this construction inside the for loop. So say I want this count to be increased by 1 every time we iterate, and say we would want to print this count instead of x, and this will have an interesting effect. If when we've been printing x we went 0, 4, 8, 12, 16 and so on, we'll now go 0, 1, 2, 3, 4, 5 and so on, but we will stop at 25 because 100 divided by 4 is equal to 25, which is equal to increasing count by 1 every 4 steps. Right, let me reiterate, because for loop is the basic that you should know as good as your own name. So the first position, the second position and third position are called the start, so this is where we start from. Then stop position, this is where we stop, and the third one is the step. This is how wide is the step in our iteration. You will encounter for loop almost in any program, so please do remember. Right, if we'll put the print statement outside the for loop, let's say we'll do the loop first and then we'll print count, that will print the final number, which is 25. That will mean that the loop has done its work and then put the output of that work into the variable count. Right, if I will remove the step, so I will leave only the start and stop, which is 0 and 100. So now the count will be increased every iteration and the final output will be 100. And if I will remove 0, so I will raise the starting point and leave just 100, so the output will be still 100 because 0 is the default position. If I remove everything, nothing will happen because it expects at least one argument. And if I'll leave 0, so you guess it, we'll get 0. And so this is how for loop works in Python. And we'll now move on to the next topic, which is the way we can store data in Python. And I'm not talking about databases, I'm talking about the data types in Python that are used to store collections of data. And we'll start with a list. So lists are used to store multiple items in a single variable. They are ordered, changeable, and they allow duplicate values. So here I've got a list of cars, say BMW, Mercedes, and number 5. And if we'll print cars, we'll get this result printed. Lists do have indices, and indices start from 0. So BMW will be at index 0, Mercedes at index 1, and number 5 will be at index 2, similar to the for loops. And as you might have guessed, we can use it in our favor. So for example, if we want to print just the Mercedes, we can put the index in brackets, such as 1, and we now printed the Mercedes. Similarly, we can add elements to the list. So if I will now remove number 5 and change it to Opel, say we want to delete number 5, remove it from the list, and instead we want to place there on the index 2 Opel, we can do that with a method called append. So I'm going to type cars, then dot, that will give me access to some operators, and I'll choose append. And inside the brackets, I'll put what exactly I want to append cars with. In our case, this is Opel. So if I'll now print the list, we should see BMW, Mercedes, and Opel. I'll also copy the print statement before the operation so we can see the difference. We can also change the elements inside the list by addressing it by its index. So if we want to change, say, a Mercedes onto some other car manufacturer, we can do something like cars1 and then equals to, say, Porsche. So list will allow us to do so. It is pretty flexible, so let's do just that. Down below I'll put cars, in fact square brackets, and I need to give an index of an element I want to change. In that case is 1, and I'll just put equals to Porsche. Not sure how you spell Porsche right, but it doesn't matter really. And I'll print our list again. So we should see BMW Mercedes, BMW Mercedes Opel, and BMW Porsche. Fantastic, let's move on. List not only allows us to swap one element to another, but also allows us to change elements that are within some sort of range. So if I will add some more car manufacturers to our list, so that we'll have more space for our experiments, say Porsche, Opel and Volkswagen. And I should also mention that we can address elements inside the list not only from the start, such as 0, 1, 2, 3 and so on, but from the end as well. So if I'll put, say, cars -1, that will print us the last element, so it will count from the end of the list. So -1 should give us Volkswagen. Yes. Similarly, -2 should give us Opel. That works. So that worked as expected. And if we'll put something like an interval, say from 2:4, that will print us the elements from the index 2 and up to the index 4. That will mean Porsche and Opel. Let's try it. Yes. So the next way to store multiple items in a single variable is called a tuple. So the difference you may spot from the start is that the tuple is using the normal brackets, and also you can't change the elements inside. So now we can see that cars is tuple. Now I'm changing it back to the square brackets. Now it is a list. But we're gonna experiment with the tuple. Let's print it out for start. So as you can see, 5 elements still present. And similar to lists, we can address an element by its index. So Mercedes is at index 1. And first element counting from the end is still a Volkswagen. So -1 for the first element from the end. Also the range from 2 to 5, we can see Porsche, Opel and Volkswagen. And we're also allowed to add duplicates to our tuple. Let's see, BMW and BMW. Let's try print it out. As you can see, we have 2 BMWs inside our tuple, and we have no warnings or errors, which would not be the case for set, for example. So, but there is a slight difference. So if I'll change our tuple back to list and say something like I want to change the first element, which is BMW, I want to swap it for a Mini Cooper. So cars 0 Mini Cooper, it will allow me to do so. So the first element becomes a Mini Cooper. If I'll change it to a tuple, and I'll try to do it now, so change Mini Cooper back to BMW, it will now not allow us to do so because tuple does not support item assignment. And of course, in many situations, we can use this feature of tuple to our own advantage. Let's move on, and the next data type used in Python to store collections of data is called set. Set is unordered and unindexed, and again it is used to store multiple items in a single variable. And set uses curly braces in its syntaxes. And now I print the set, and as you can see the order is not preserved. So I can get rid of these indices, and if I'll try to assign something by index, I'll get an error. And in that case, all we need to do is use the loop. For example, we can use the for loop, the classical for loop, for this task. So I'll type for car in cars. So car is going to be our variable that we're going to use to traverse inside that loop. So in this case, we're going to loop element wise inside the cars set. And if I'll print it now, you can see that it has just printed our set 5 times. And as you can see, every time I run the loop, the order of the elements was different. But if I'll change cars to car to actually the name of the variable that we use to traverse, this time we're gonna get each element of this set rather than the whole set. So this is one of the downsides of set, but on a positive side, unlike in the tuple, we can add elements to our set. And it even provides a special method in order to do that. It's called add. So we can type cars.add, and inside the brackets, we're going to specify the element we want to add. Let's print our set again. And as you can see, now we have 6 elements, but they are all in random order. And since the order doesn't matter, we can actually add several elements with one method. So this method is called update, and inside the normal brackets we have to use the square brackets, and inside those square brackets we can comma separate the elements we want to add to our set. So in this case I'm adding Citroën, Renault, all those French cars. And this should give us a set of 9 elements, 9 cars effectively. And if we'd like to find out the number of elements in our set, effectively this is the length of our set. We can actually use the specified method, special method to do that. So I'm gonna go with cars, and I'm gonna put it inside the brackets for the len method. Len is a short for length, so prints the 9. So we have 9 elements in our set indeed. And in case we want to delete an element or elements, we can use a method called remove, but since we cannot address an element by its index, we have to specify it by the key. So if we delete Citroën, we get 8 elements in our set. And if we'll remove another one, say Ford, we can get an error because there is no such thing as Ford in our set. But if we don't like to see this runtime errors, we could actually construct some condition. Let's say if Ford is present in our set, then we will delete it. Or if something is present in our set, we'll delete it. Otherwise, we'll throw an exception. And we'll talk about the exceptions later in this course. So we could either do it like that. So if Ford in cars is equal to true, we'll remove Ford from the cars set. Otherwise, so we type else, we actually print a message. We don't have this car. And if say we want to have a more generic condition, we can replace the Ford with a variable, say x, and now we could just use the same condition, but we can just swap the values for the variable. So we tried with Renault. So Renault is in the set and is now removed. But if we'll try something else, say Lada, then we'll get a message, we don't have this car. But I've actually forgot the print method, so I'll add it now. So we're going to print that message and I'll rerun the program. And as you can see, we have a message, we don't have this car, and the rest of our list. And if I'll remove the last print statement, we just get the message. But I guess the Python programmers were eventually fed up with writing these if-else statements, and they came up with a method that is doing the same thing as remove, but does not cause a runtime error. And as a homework, I'd like you to go and see the set documentation and put in the comments what this method is. But we'll move on. And the next type of collection that I'd like to talk about is called the dictionary. So dictionaries are used to store data values in key value pairs, and it is ordered and changeable and does not allow duplicates. It uses curly braces as well as set, but this time we need to specify the key value pairs. So if I'll type BMW, I'll open and close the curly braces, and inside I'll put something like make for the car make, and I'll specify BMW as the value. So make as a key and BMW is the value. Then goes the model, let's say something like i8, the electric hybrid, and the color is gonna be white. And if I'll print the BMW, so I type print and I pass BMW as an argument, and you can see that it has printed all key value pairs separated by the comma. And we can also change the values of our keys and values. And in order to do so, we just specify the key, so the string, let's say color. So I'm using the square brackets, and inside I put color, and I assign a new color, say black. And if I'll print the BMW again, you can see that color has a new value, which is string black. And similar to sets, we can find out the length of our dictionary by using the length method and passing BMW as a parameter. And it prints out that we got 3 key value pairs in our dictionary BMW. We can also iterate through our dictionary. Let's say we want to print all the keys. So we're going to use the for loop for X in BMW. We're going to print X. So without any additions, it's just going to print the keys. So we have make, model, color, and this is the 3 is from other print. I'll delete it. But don't forget that variable we use for iterations, it needs to be inside the square brackets. And if we want to loop through the dictionary and print the values, we can use the method called values. So I type in bmw.values, and inside the print statement I just print X, and this should be enough. No, it's not. What have I forgot? So values as a method should be ending with brackets. Okay, so these are the values of our keys. If we want to do both keys and values, we can specify 2 variables, say X and Y, and instead of values, we're going to use the items method. And we're going to print both X and Y, and this is showing us the keys as well as their respective values. But what if we want to get a specific value rather than printing all keys or all values or both? So in order to do that, we can do a method called get. So I'm assigning the value of bmw.get to x, and then I print x, and I want to get a value of the key make, and this is indeed the BMW. We can also easily add key value pairs to our dictionary, so I'll show it in a second. I'll just get rid of all that. And if I'll write BMW, and inside the square brackets I'll specify the key and the value outside the square brackets. So let's say year is 2020, and if I'm going to print our dictionary now, we can see that it was appended with another key value pair, which is year 2020. And if you want to remove a specific key and its respective value, we can use a method called pop. So I type BMW pop, then I put just the key name, year, and I print the BMW before and after. So as you can see, in the first case we have year, and in the second one we don't. Let me add the year again for the next experiment. So let's make sure, yes, it came back. And I'm going to show you another method which is called pop item. So from Python 3.7 it removes the last added key value pair. So we should get the same result as if we would remove it with the key. But let me first check that I'm running the right version. So it's 3.8.6, that should be enough. So let's print the BMW, and pretty much it is the same result but without extra writing. And if we want to copy our dictionary, we can use a method called copy. Let's say we decided to add another dictionary called Mercedes, and I'm going to assign, so I'm going to make it a copy of BMW, and then I'm going to change the key value pairs. So essentially the values, I'm going to leave keys as they are. So if I'll print the Mercedes now, it's going to be a complete replica of BMW dictionary. But before I'll do that, I'll show you another method which is called clear. So that essentially will gonna clear all key value pairs from our dictionary. So if I'm gonna type Mercedes clear, of course nothing happens because we need another print statement. So I'm gonna copy it right after the Mercedes clear method, and as you can see we have an empty dictionary. There is another more straightforward method to copy dictionaries, which is just assigning a dict as a dictionary to the variable. Let's say we want dictionary called Porsche, and we're going to make it equal to, we're going to assign the dictionary Mercedes, and it's going to produce another empty dictionary, but this time without a method called copy. And we can also use the similar approach to populate our dictionary, and we'll start with Mercedes. So I'm going to type Mercedes, then I'll assign the dictionary dict, and inside the brackets I'm going to be typing the key value pairs. So make equals to Mercedes, then model is going to be equal to, let's say, S-Class, saloon, and should make it proper string. And color is going to be equal to white, or rather black. And if I'll print our new version of Mercedes dictionary, we're going to see, but it's not empty anymore. It is rather a normal dictionary with make, model and color. Nothing restricts me from adding more key value pairs, but I just want to make it consistent. So I can do Porsche, and inside the square brackets I can put make Porsche, and this is another syntactical way to populate dictionary, but with a single, this time with a single key value pair. So make Porsche, and I can do the same for the model and color, but I don't want to. I'll rather delete this Porsche. So I'm using the method del. It's that easy. And if I'll try to print Porsche now, we're going to get runtime error. It's not such dictionary. And we can also store multiple dictionaries inside other dictionaries. So in this case, I have a dictionary called cars, and it consists of 3 dictionaries: BMW, Mercedes and Porsche. So in this case, BMW, Mercedes and Porsche are the keys, and I can copy what used to be a key value pair inside the BMW dictionary itself. So I can make it as the value for BMW. And I'll do the same for Mercedes and Porsche. So a lot of copy paste is going on. So I'll make the structure consistent. So make Mercedes. The model will be S-Class Saloon. And let's say the color, we'll leave the color as white. And Porsche, of course, it's going to be make Porsche, then the model Carrera GT, and we're going to make it black. So now we have a dictionary cars that consists of 3 dictionaries: BMW, Mercedes and Porsche. And of course, what we're going to do now, we're going to try and print it to see what it looks like. So I'll make sure all the brackets are nice and line up. That's better. And now I can loop through our dictionary the same way as we did through the single dictionary. And if I'll print it, so it's going to print 3 keys: BMW, Mercedes and Porsche. And again, I can print the key value pairs by declaring 2 variables, x and y, and we'll use the method called items, which we already know. And if I'll print our x and y now, we'll get the dictionary of dictionaries. Let's move on. The next topic is the string. Let me clear the screen. By the way, you can play with it, try other methods or adding and removing, but we'll talk about strings now. So I'll declare my string and I'll assign the value Ave Coder, and a simple operation, print my string, and we should get an Ave Coder printed to our screen. Indeed. And as you can see, we have spaces before and in the beginning and in the end of our string. I can slice the portion of my string from the index 3 to up to the index 7. Let's see. So that prints us E, comma, space and capital C. So elements inside the string are counted from 0. So if I'll enlarge the range to 10, we'll see that we're going to have more letters printed. And similar if I'll do the negative index, so I'll count from the end of the string. So we'll see that I only have 3 letters O, D, E. which is the slice from the 5th position up to the 2nd position, but counting from the end of the string. By positions, I of course mean indices. And if we want to find out how many elements we are getting inside of our range, we can use the len method, and we're going to put the myString slice inside the method. So indeed, we're getting 3 elements. There are also 2 interesting methods, which are lower and upper, which is going to convert our string and all elements. Say we have the uppercase letter or uppercase letters, and by using the lower, we'll convert everything into lowercase letters. And on the contrary, if I'll put upper, now everything is caps. If we want to swap values of any of the elements, we're going to use the method replace. So first argument is which symbol we want to replace, and the second argument is the value of the replacement. So as you can see, we have now the same string Ave Coder, but coder is written with the K, and similar. And if we want to split our string into 2, we'll specify the criterion by which we'll split, say a comma, and we'll use the method split. And now you will see that there are 2 strings, Ave and coder, and comma is no longer a part of a string. And if you'll recall, our string is prepended and appended with spaces. So to get rid of them, we can use the method strip. And this is useful in passing the login and password fields values in, say, authentication form. We'll make sure user does not put any extra spaces. All right, so let's move on. We'll specify another string called Ave, and we can check whether myString contains our Ave string in it. To do that, I'm going to use Ave in myString, and if I'll print Ave now, we'll get the Boolean value, which is true, because of course Ave Coder has Ave and coder. And if I'll reverse the condition, say not, then I'll get false. And now 2 words about the placeholders. So these are essentially the places basically where you can put some other values later on. Let's say we have a variable called name that consists of 1 character v, and we have my new string, which is Ave, and then I'm using the curly braces with the exclamation mark. And if I'll print something like my new string and use the method format, and then inside the format I'm going to put my new variable name, so the Python will automatically replace that curly brace with the value of the name variable. And we can also change the hard-coded value of our variable name onto something that, say, a user can type in. To do that, we're going to type input, and now it's going to read the input, and it's going to replace the placeholder in the my new string. Let's say Julius, and it's going to type Ave Julius. So it has replaced those curly braces with our input. And now that we know how the user input works with the placeholders, we can create a popular kids game called the Mad Libs. So let me delete all that, and we can begin to write our Mad Libs game. So let's say we'll have a series of variables. First one is going to be called the direction 1, and its value going to be hard-coded to turn right, and the second variable is going to be direction 2, and its value going to be turn left. You can see where this is going. And direction 3, it's going to be turn left, then right. So imagine someone asks you how to get somewhere, and now I'm going to declare a variable called path to the shop. So someone's trying to get to the shop and is asking you for the directions. So you say first placeholder, then there's another placeholder there, and finally the third placeholder. And I will finalize this with, and you will get there. So now that we've got our phrase ready, we can start to substitute the placeholders with our variables. So I'll take our phrase path to shop and I'll use the format, and inside the brackets I'm going to list the variables, and now we get the final phrase: first turn right, then turn left, and finally turn left, then right, and you'll get there. And again, if I'll change the order by which I'm passing those variables into the format method, this will affect the final phrase because it will sort of shuffle them around. But instead of tediously changing the order of these variables, I can do something neat. I can actually amend the placeholders we have in the original phrase by adding indices. So let's say our first placeholder will have index 1, then second is 1, and the is 2, and say the final is 0 again. That way we'll shuffle around our variables. So instead of what we had before, now we have first turn right, this is the direction 1, then turn left, then right, this is direction 3, and again turn right, this is again direction 1. But it's all still hard coded. What if we want to make this game a little bit more interactive? So let's do a new scenario. Say we have a price which is 99, an integer, and we have a full price which is a string that says the full price is, and then the placeholder, and then we have the colon and dot to f. That means that when eventually we're going to print our full price by using the method print and then method format, we're going to pass price as an argument, we'll get 99.00. So this 2f means how many digits we'll get after the dot. So if I'll change it to 3f, we're going to get 99.000. So this was another scenario, another way how we can use the format. And now imagine we will declare a new string, let's say my order, and it's going to be equal to the string I will have, then placeholder, and here I'm passing the key. So the key main as main. So imagine this is something like you ordering your food in a restaurant. So pretty much the same thing like in the first scenario with directions, but this time instead of indices we are using the actual names of the variables, the actual keys. And if I'll print my order right now, I'll use my order format and I'll pass value for the key main as chicken, and the side is going to be equal to, let's say, corn. So if I'll print it now, I'll get something like, I'll have chicken as a main and corn as a side, which is neat. That way I can change the values of the keys. Say main is now equal to fish and side is equal to chips, and now I'll get fish and chips. I'll have fish as main and chips as a side. Let's move on, and now I want to talk about something that's called the escape characters. So let's consider the following example. Let's say I want to print a string, which I enclose in double quotes. The string is why mighty flosses always win, or always lose rather, to Aspire Bakers. This is my question about some sport teams all the time. But what if I require those names, Mighty Flossers and Aspire Bakers, to be inside double quotes? So I want to quote the names of the teams. Now the Python will think that there are several strings in my print statement. The string why, the string always lose to, and the string all the time. So it has excluded the Mighty Flossers. So escape characters, this is a trick, will help us to tell the Python that this is not an actual double quote. You don't need to act on it. This is just something from the text. All right, let's move on. There are two more string methods I want to cover. First one is called find, and the other one is called count. So let's imagine we have a string called myString, and it contains Ave Coder. And so let's say I want to find out whether myString contains a specific symbol, and I'm using method find, and here inside the quotes I'm passing the symbol. So in my case this is uppercase letter C, and I'm going to print what it returns. It should return the index. So as you can see, the index 4, this is right because everything counts from 0. And Ava is 0, then V is 1, E is 2, then space, and C is 4. If I'll change it to E, I'll get the index 2, which is again precisely where the letter E is. But if we'll try to allocate, say, something that does not exist in text, we're not getting the error, rather we're getting a -1. Right, so the next method we're going to look at is called count. So it's going to count how many times does letter Z is repeated in my string, which is none, so 0. And I'll change it to E, and indeed we have 2 letters E in our string, Ave Coder. And if I'll change it to something like capital C or other lowercase c, it will return 0 because the method itself is case sensitive. But we can do a little dirty hack. We can use the method we know already, which is called upper. So we can literally move all characters into the uppercase. So I'm going to type something like myString.upper, and I'll do the same for the character C. So I'll do C.upper, and it should return 1. Yes. All right, so we're done with the introduction into strings. So let's talk about the functions. So functions in Python are defined with the keyword def, and it is followed by the name of the function. Let's say I want to call my function Barry says hello, then brackets and colon. Then it is very important to keep everything indented. And let's say it's a simple function that prints something like woof woof. So let's say Barry is a dog. So now I can call this function by its name, say Barry says hello, and it will return what it's supposed to return, which in our case is woof woof. So if I'll launch it now, we get woof woof. And this is of course a very simple example. We can do all sorts of stuff inside of our functions. So for the next example, I'm going to create a new function that will multiply the numbers. So we're going to supply this function with some numbers as an input, and it will produce their multiplication as an output. So let's say def multiplier with a parameter x, and let's say it will return the result, which is equals to x times 2. And we'll return the result. And now if I'll specify the value for the variable x, so I'll print multiplier, this is the name of the function, and I specify the argument, which is 2. We need to print it. So we should get the return the inner logic of this function, which is multiplication by 2. And this is something that's called parameterized function. So we can change the values to 3 and 4, and as you can see, this is a 4, 6 and 8 respectively. We can also input several arguments at the same time. Let's say I'll get rid of that, and instead of just x, I'll put x and y, and this time we'll return the multiplication of x and y. So in this case I need to pass 2 arguments into my function, and I should get 10, which is 2 multiplied by 5. Bear in mind that the number of arguments we pass to our function call should be equal to the number of argument it expects. So if I'll just put 2, I'll get the runtime error. It expects another argument for y. Functions are the cornerstones of any programming language, and you'll meet them obviously a lot in Python. And let's have a look at another example. So this time let's say Barry is not a dog, but let's say Barry is a parrot. And now we can pass something that's called arbitrary arguments. So let's say we don't know how many arguments will be passed into our function. So we add an asterisk before the parameter name in the function, and this way the function will receive a tuple of arguments and can access the each argument accordingly. So we type asterisk and then my words, and now I can type as many words as I want. So we'll print my words, and inside the function call I can put for start just hello, so it prints hello. And let's say I wanted to return several strings. For example, I want our parrot function to say hello Barry. I need to split them. So at the moment this is just a single string, but if I'll comma separate several strings, let's say hello Barry, so these are going to be separate arguments, we'll still return those arguments despite it's more than one. It will not throw a runtime error that there are too many arguments. So this is the power of arbitrary arguments. And so we can actually expand a little bit on that, and instead of just the arguments, we can pass the key value pairs. So inside my function we'll specify a string, say good, and then concatenate it with a variable of whatever value we're going to pass into that function. So I'm going to change it to say breakfast time, and in here breakfast time as well, and I'll add a couple of more. I'll just leave it for breakfast time for the moment. So I'm going to pass into the function that breakfast time is equal to morning. I'll delete that cheeky comma and we can launch it. And as you can see, it was successfully concatenated. It now says good morning. So let's add some more arguments to the function call. This time we say nothing happens, and this will be equal to the afternoon. And finally we can say dinner time, and it's going to be equal to the evening. But now we need to add extra parameters to our function. Let's say we have breakfast time, we have nothing happens time, and we have dinner time. And now by changing the parameter inside of our print method, we can display various time. Let's say good evening, that's for the dinner time. And you can play with it in your own time. So let's move on. I'll get rid of all that. But what if we want to specify a function that does nothing? Let's say we want to implement this function later, but we don't want to forget about this. So we're going to introduce something that's called the pass function. So we can just put the keyword pass into the function's body and nothing happens. Before we'll move on to the different topic, I'd like you to open the documentation and have a look what the quarks are, and put this in the comment below the video. But our next topic is the work with the files, how we can use Python to read the files, delete parts of it, or append it with some other text. So we have this classic lorem ipsum, which is basically a text placeholder, and we're going to be experimenting with it. But before we'll do anything with the text file, we need to make sure it is opened for Python. So to do that, we'll declare a variable file, and then we'll use the method open, where we specify the name of the file. Just make sure it is in the same directory as your main.py. Otherwise, you need to specify the root, specify the path to the file, and then we need to specify what do we open this file for. So there are several parameters such as R for read, A for append, W for write. And if we want to create a file from scratch, if it doesn't exist yet, we can use the parameter X. X stands for, surprisingly, create. And we can pass one of those parameters into our open method. In our case, we want to read the file. So we're going to pass R inside the quotes. And now we can print the file. Let's see what's going to happen. And we got an error. And in this particular case, it is telling me that no such file exists. So the Python cannot find this file. So we need to specify the path. I'm just copying my path to that file, and it doesn't work. So let's have a look. Unicode escape codec can't decode bytes in position 2, 3. So this is something to do with the path to the file. So because I'm using Windows, I have backslashes, and we need to escape them as we did with quotes in the escape characters part of the course. So now it tells us that the file is indeed found and opened, but it doesn't work as intuitively as we thought. So we need to add a method to the file variable. So this is what we want to do with the file, and we want to read it. So that is the file. So it displays the content of the whole file. But if we want to say read just one line, say the first line, so we're going to pass the readLine method that prints the first line. And if, for example, we want to read just first a couple of letters of the first line, say lorem ipsum, so we're passing the argument 5, and that prints the first 5 letters, so essentially the first word. And we can also use for loops to iterate through the file content, and in our case that's going to be a simple for loop for x in file, and we're going to print x. So let's give it a go, and as you can see, it has printed all lines of the file. When we've finished with the file, we need to close it, because otherwise it will remain open and will continue to consume resources. So that case is not a good thing. So let's have a look how we can actually modify the file. So in case we want to append something to the file, we need to change the parameter r to a, and now we can use method write, and we can pass what do we actually want to append this file with. In my case, this is going to be a simple phrase. This is written in Latin, and we close the file after the operation. And let's read the file after we appended it with the phrase. And we do print, read, and now you can see, if I'll scroll, you can see that the file is written in Latin, was added to the very end of the file. By the way, those parameters we're changing correctly are called the mode. So if I'll change my mode from append to write, and I'll leave everything else the same, we can see that now the text is gone and the only thing that is left is our line. So the text was overridden by what we've put as the argument. And by the way, nevertheless, we have a separate mode for creating files, which is X. We can also create files with W, with write mode, by just specifying a name of the file that doesn't exist. So in our case, this is Ave.txt, and we'll try to read it. We'll assign it to a new variable. It says not readable, and of course that is the case because we didn't change the mode. So we need to repeat the whole process with reading file. So I'll just change the name of the file, Ave. And now it should be working fine. It has returned the content of the file. So I need to modify the variable. And this time returns nothing. So the new file was created, but it is completely empty. Alright, for now I will comment out our previous exercises. So we'll be just left with file 2. So I'll comment all that out. And we can continue our experiments on file 2. So our file is currently empty. Let's correct that. We'll use method write and we'll put file number 2. And now as we read file 2, it comes back with file number 2 string. Right, so what if we want to delete the file? In that case, we'll be working directly with operating system, and for that we need a separate library called OS. So I'm going to import it, and in here I'm going to specify that I want to delete file 2. So in order to do that, I'm going to call OS and .remove. And in here I need to specify the full path to the file I want to remove, which in this case is going to be ave.txt. So please don't mix it up with the name of the variable, file 2. And I'm gonna get rid of it and copy it further down below so we can actually check that the file does not exist, no such file or directory. So file was successfully deleted. And importing libraries is the common practice because there is no point writing something from scratch. We can just import the library that was already implemented and use the methods and functions inside that library. So you can have a look at the list of Python standard libraries, and there are also very famous ones like pandas or NumPy, which we'll talk about in a separate video. But I should say that there are tons, literally tons of libraries written for Python. But we can also do something similar ourselves. So for example, we can create a separate module and implement some function in it, and then import it into our main.py and use that function inside of our main file. So let's say we have hello module.py, and here we define a function, say hello. That function takes one parameter, which is name, and let's say it just prints hello plus name. So essentially it's going to print the greeting. Right, we save it, and then we come back to the main.py, and in here we can import hello module, and then we can call the function of hello module, say hello, and here we are passing the argument. Let's say we wanted to say hello v, and if we'll launch it now, it returns hello v. So this is pretty much the explanation of how those imports work. And if we don't want to use the long name, we can actually do an alias. So let's say import hello module as hm, and now we can call hm instead of hello module, but the functionality will stay the same. Right, so this was a brief explanation of how imports work. Next topic, we're going to talk about the scope. I should also mention that we're going to have a separate lecture on object-oriented Python, but here we'll just merely scratch the surface, but still we need to understand how it works. So I'm defining the function called funky, and inside the function I'm doing assignment. I'm assigning 10 to a variable x, and then I print the x, and I'm calling the funky, and so it returns 10, which is as expected. And as you have noticed by far, Python is an indented language, so indentations, they do play a massive role. So if we'll define another function inside of our function, let's say this is going to be inner funky, we'll move our print method inside the inner funky, and outside of inner funky we'll call it. It still returns 10, so the call to inner funky is still happening inside of the function funky, and that's why it returns the value of x, which is defined at the same level as the call to inner funky. But now let's consider a different scenario. We have the assignment outside the function, so inside the function we'll get rid of that inner function, and of course we need to get rid of the call to that function, and we'll leave print inside and outside of that function. And as you can see, it prints 10. There's no problem with getting that value of x from within the function and from outside the function, of course. But what if I will declare another variable x, but this time inside the function? So inside def funky, I'll say x equals 5. So what those print statements going to print now? So because the new assignment is treated as local to the first print statement, it's going to print the value of 5, and of course the print statement outside of function will operate on the same level with the x outside the function, and it's going to print 10. But if we would want our local x to be accessed from within the function and from outside the function, so we can use the keyword global, and we can declare it as a global variable, which you should be careful, because in some cases it may have unpredictable repercussions. So we defined x is global, and now print statement from outside the function treats the x local variable inside the function as the global variable, so it forgets the value of x equals 10, and now x equals 5 is treated as if it was written outside the function. So both print statements print the latest value of x from within the funky. Alright, so that's all on this topic. As I've said, there's going to be a separate lecture on object-oriented Python, and we move on to the last topic of today's lecture, which is exceptions. So we've seen all those red runtime errors when things didn't go as we planned. And of course, the runtime error stops the program execution. And is there a way to avoid that? Yes, there is. This is the right topic, which is exceptions. So what they allow us to do is, in a way, to predict the misbehavior of our program and sort of instill a precaution into our program. So with the keyword try, we specify what we expect our program to do. So this is the path when everything goes well. So in this case, we have a variable phone number, which reads the user's input. So we basically read the user's input and we print what was typed in. So again, a try is wrapping up the part of the program where we think everything will go well. So we'll take the input and it will print your phone number is and the value of the variable phone number. But in case something will go wrong, we need a precaution, the keyword except. So this is the part where we specify what to do in case the code in our try part didn't work correctly. So just in case something went wrong in the try, we will print something went wrong. Please try again. So it's a pretty similar logic to the if-else statement. So if everything is okay, we'll do this part of code, else we do that part of code. It is actually so lookalike that we literally can use the else keyword. And for example, here we'll specify everything works okay. So our try block has completed and successfully printed out the phone number, and we'll append it with a statement that it's working okay. So we're going to type in some fixtures phone number, and as you can see, here's your phone number, it's working okay. But if we want some piece of code to be executed despite of success of try, or in case it throws an exception, so a piece of code that will be executed regardless of what happens with the actual code, we can use the keyword finally. So in this case, we'll print, I'll print it, you like it or not. So once again, this is one of those whatever happens moments. So if we'll launch it again, we can see that we need to type in the phone number, we do, and it's working okay. I'll print it, you like it or not. But let's try to diverge our program into a different scenario where it throws an exception. So as you remember, user's input is string by default, so numbers or letters doesn't matter. So in this case, we're going to cast it into int, so to make sure the input is actually a bunch of numbers. So we'll type in numbers with letters, and so the exception been thrown. Something went wrong, please try again. And then the finally statement is printed regardless of the outcome. The finally bit is very useful in case, for example, you have a file that needs to be closed regardless of what is going on with the writing or reading the file. otherwise it will consume resources. So this was the first scenario on how we can throw or raise exceptions. But the second scenario, we can literally raise them in various parts of the code. So imagine we have a variable this time called x that reads user's input, and we're going to cast the input to integer straight away. And then we have a series of conditions. For example, if x is less than 0, we're going to raise an exception. So rather than just printing something like the x is negative, enter some bigger value, we can do pretty much the same with the keyword raise and an exception. And inside the brackets, we put something like x can't be less than 0. So it is pretty much the similar construction as if we would just have a print statement, but this time it is done via the exception mechanism. Another scenario is when, for example, x is not an integer. Rather than writing try, except, and all that, we can just write if not the type is int. So if it's not of a type integer, we'll raise the exception of a special type. So exception is the generic word, but exceptions do have types. For example, we have a separate type error just for this scenario. All right, congratulations, you made it to the end. Ave Coders, and welcome to this wonderful course on how the object-oriented paradigm works in Python. You will make yourself familiar with linear inheritance, multiple inheritance, encapsulation, polymorphism, interfaces, and how composition works, as well as abstract classes and methods. I'm going to be using VS Code because, well, I could say that, it's free, convenient, etc., but I just got used to it. Plus, you can add extras to it, which I'll recommend you to do. For example, I'd recommend you to install the Python extension for Visual Studio Code. That should make your life easier and your hair shiny and healthy. Just kidding. All right, so without further ado, let's kick in. We're going to look at some basic principles of OP, and we're going to do that on examples. So I will code some of the examples, some code from scratch in order to illustrate my points. So here I'm creating a class called car, and by convention, the class name in Python should begin with the capital letter. And I also use the pass inside of that class, generally specifying that the class is empty, does nothing. So whenever the interpreter will stumble upon that class, it will just pass through it. And down below, I'm creating an instance of that class. So essentially, I'm using class car as the blueprint to create an object of that class. And since the class car is essentially empty, we just cannot leave it empty. We have to fill that void. So we did it with pass. So car1 does nothing as well. So let's define our first method inside of that class, which will be, of course, init. The init method is essentially a constructor which is responsible for the object initiation. And it has two parameters, self and maker, of which you can see self quite often in the Python code. It basically is a parameter that is a reference to the current instance of a class, and it is used to access variables that belong to that class. And naming self as self is just a convention. And here you can see I'm updating our code. And as you might guess, maker is just the name of whoever makes the car. So BMW or Mercedes. And we have to pass them as arguments. Because this is something that class car expects. And this is something that we need to specify in order to create an instance of that class. And notice that we didn't have to create a new class for BMW and another one for Mercedes. This is the power of using classes. We can have one class but many objects, each of which could be instantiated with a different attribute. So let's print them out. And what we're actually going to see is the address of that object in memory in case of car1 and the maker in case of car2. This is because we specifically called for the maker attribute via the dot operator. If it is a bit too overwhelming for you at the moment, I would recommend you to take my Python for Beginners course via the link in the description. All right, so since we now understand the basic principles of how classes work in Python, let's extend our class car. Let's add model, color, and let's say price. And we also need to add them to the body of this init method. So I'm adding self.model equals model, self.color equals color, and self.price equals price. And now that we have a little bit more in our init method inside of the car class, we'll also need to update the code at the point where we create the instances of that class. I'm talking about car1 and car2. So at the moment we only have maker, so BMW, but we also need to add the rest. And I'm going to generate this as we go. So from the top of my head, we now need to specify the BMW model. So let it be i8. Unfortunately, they've stopped making it, but still. Then we need to specify the color. So let it be white, because white is an absolutely stunning color for i8. And let's say the price, I'll pick some random money, 50,000 of some money to get rid of the floating point. And the same for the Mercedes. Let's say it's going to be anything in C class and will be of a black color. And let's say the price will be equal to 28,500 money. And if we'll run it again, then nothing will really change. But let's say we want to create some instance method. So I'll go back inside my class and I'll define it as something like getPrice. For instance, I'll pass self and it will return the price. So self.price. So the price of our car. And in here, I can call this instance method via the dot operator. Let's see. Now we have 50,000 of these units printed as expected. And rather than getting something, we can also be setting something. So we can define a new instance method called setDiscount. So let's imagine we decided we'll apply a discount to a certain car. And of course, we'll need to specify the amount. So we write self._discount equals amount. So what does this underscore prefix means in Python? This is to give a hint to other developers that this attribute is internal to the class and should not be accessed from outside of the class's logic. Other object-oriented languages like Java, for instance, it has the mechanism to enforce this logic. But Python basically appeals to developers' consciousness and expects them to stick with the convention. All right, and let's put another piece of logic that will check whether we have this discount specified. So not all instances of the class or objects would have the discount applied to them, or in other words, would have the price modified by the discount. So we're going to use hasUtter function to check whether this attribute is present. And if it's present, we can apply the discount logic to it. So the price minus the product of price and the amount. And if the attribute is not there, then we will return the unmodified price. So I'll move it under the else branch. All right, so now that this is done, let's see this in action. Down below, I will move to where we have our prints, and I will call the setDiscount method on our car2 instance of a class car with the value of 0.25, so 25% discount. And on the next line, I'll print the car2 price with the discount applied. So similar to car1, we call getPrice on car2. But the difference will be that we have set the discount for car2. Therefore, as you can see, the price is displayed with the discount applied. I'll remind you the original price was something like 28,500 of units of money. And here is another mechanic which I'd like to discuss. So for instance, imagine that inside the init method in the car class, I have created a new attribute called secretCog, and it has got the double underscore prefix. And when I do that, Python interpreter will change the name of that attribute. And now any other class that tries to access it will get the error. And this is called name mangling. So let me illustrate the point down below where I'm trying to call the secretCog attribute via the car2 instance of a car class. So let's try to print it, and we should get an error. And the error we get, it reads attribute error, car object has no attribute secretCog, so it can't literally see it. So essentially what it does behind the scenes, it prefixes the name of the attribute with the name of the class. But if I'll precede the name of the attribute with the name of the class, so in this example, I can write something like underscore car, which is a class name, and then double underscore secretCog. Then we can see it goes ch, which must be it's some kind of secret behavior. And speaking about the behavior, since this is a video on object-oriented programming, where classes can inherit states and behavior from their parents, and objects can be created as instances of those classes, I think it will be beneficial if we look into the functions that can help us to define the type of the object. And for that matter, let's create a second class, which we'll call, well, motorbike is kind of a car in a sense. Let's call it boat. So this is completely different from car in any sense. So define the init method. And I don't want to write too much. All I want is to illustrate the point. Therefore, the only attribute it will have is going to be its name. And now that we have our boat class, we are ready to do some manipulations. First, I'll create an instance of that class and I'll call it boat1. So it's going to be an instance of a class boat, and it's going to have name Titanic, of course. And below that, let me clear some space. Let me actually get rid of those print statements. All right, and now we can use the function type. So I'll print type, and inside the brackets as an argument, I'll pass car1, and similarly, I'll do the same for the boat one. And as you might have guessed by now, it's going to print the name of the classes, which effectively represent the type for those objects. So car1 is of a type car and boat1 is of a type boat. And now let's see what is going to happen when we'll try to compare, let's say, car2 type and boat1 type using the double equal sign. And of course, since they are instances of different classes and classes represent type, we will get false. You can try to play with it, substitute those objects with other objects, but it is pretty straightforward. What I'd like to do is I'd like to shift our attention to another function called isInstance, which checks whether some object is instance of some class. So for this example, I'll type something like isInstance, and then inside the bracket as an argument, I'll pass the instance under the check and then the class. So if car1 is an instance of class car, then it will return true. And for the second example, I will use boat1 and I'll check whether it is an instance of class boat. So the first two print statements will give us true, while we need to add some false statements just for contradiction. So boat1 is instance of class car and car1 is instance of class boat. Let's comment that out. And the result should be boring and, as expected, true, true, false, false. The standalone examples might look a little bit boring, but the function isInstance might be very helpful when you trying to do some kind of a check. So if isInstance function returns true, we do one thing. If it returns false, we do something else. And as you might have heard in object-oriented languages, everything is an object. Therefore, every object inherits from the grandfather of all objects, object. And of course, it will return true in both cases because indeed car1 and boat1 inevitably inherit from object. And now let's talk about some other types of methods and attributes. One of them is static and the other is what's called the class level attributes and methods. So the type of methods and attributes we've been extensively studying so far, it's called instance methods and instance attributes. For example, setDiscount is an instance method and discount is an instance attribute, because its value is associated only with an instance that gets created from that class. On the contrary, the class level attributes are shared by all instances of the class. And to solidify your understanding with an example, I've created an attribute called purchase types, which is a tuple where we essentially specify how you can buy our car. And currently you can do that with lease or cash. And let's imagine that we need some kind of a method that will return those purchase types. And as you might have guessed by now, it will be a class method. Therefore, I'll use a decorator that will specify that this is a class method. And because it works on the class instance, not an object instance, I'll need to pass something I will define as CLS, as for class, instead of self. Therefore, in return statement, I write CLS.purchaseTypes. If you want to learn more about these conventions, you can refer to the document called PEP8. Of course, I could have left the link in the description, but I was told that something called Google was invented recently that allows you to search and eventually find anything. And we also need to add those purchase types to our init function. Let's assume that our car dealer is very conservative, and since we only have two purchase types, which is lease and cash, but there are more of them out there in the wild. I've heard that some car companies even accept crypto. Therefore, we can do a little check down below. So if the purchase type is not in this tuple purchase types, then it will raise a value error. And inside this value error, we can put some polite statement saying that the purchase type that you have offered is not basically valid, so we cannot accept it. So it is not a valid purchase type. However, if the purchase type that the instance of the class car will be instantiated with is present in the tuple, then we'll say self-purchase type. So else self-purchase type. In other words, it is valid and we accept it. All right, and now that we added this class attribute and class method, we'll need to expand our car1 and car2. We need to add them, but first let me comment out the print statements. And now let's add these purchase types to car1 and car2. Let's say for car1 it's going to be cash, and for car2 it's going to be lease. And let's write some print statements. We'll begin with the generic. I'll comment that out. We don't need the boat. So we'll begin with a generic print statement that will essentially print what purchase types do we have in our class. So I'll type purchase types, colon, and then will be car dot get purchase types. This is just a simple check in case we'll run into a problem. So we have lease and cash. All right, as expected. And now we'll print the purchase types for car1 and car2. So I'll go for car1 and car2. And same as we did before with instance methods. So we have car object, and this is the location in memory. This is all good. And now we can use the dot operator to access the purchase type. And let's see, we have cash and lease. Brilliant. And now let's see what's going to happen if we will use some purchase type that is not existent in our class. Something like swap, for instance. Then we get a value error. Swap is not a valid purchase type. So we get the expected behavior. All right, now let's have a look how static methods work in Python. Here's a little bit simplistic explanation that static methods earned their name, static, because they don't really modify the state of class or specific object instance. And we'll see how they work in just a second, but let's do some preparations for this example first. So let's define an attribute called sales list, which is prefixed with double underscores, which essentially make it a private variable, and we'll initialize it to none. And then we'll define a static method that will expose this sales list to the consumers of the class car. And similar to the class method, to make the method static in Python, you essentially write a decorator static method. So this static method will return the sales list. So if car sales list is none, it will create one. Otherwise, it will just return the sales list. So basically what we're trying to do here is to implement a singleton design pattern, which basically ensures that only one instance of an object or a variable ever gets created. And this get sales list static method can essentially help us to add sales to our sales list. So if we defined a sales this month variable here, and we can use the dot operator to get sales list. And on the next line, I can write something like, well, print it first, print sales this month. And we have value error. This is because of that swap. Let's change it back to lease, and we'll try to run it again. And now you can see we have an empty list. So on the next line after the sales this month, we can write something like sales this month dot append, and as an argument we'll pass, say, car 1. And similarly, the next line gonna append car 2. And as you can see, we have now a list with 2 objects, car 1 and car 2. I hope that is clear, because we need to move on. And the next subject will be the inheritance. And let me briefly remind you what inheritance is. All right, so let's imagine we have a class. The class has attributes and methods that define its state and behavior. And let's imagine we decide to create another class, but rather than define states and behavior from scratch, we say something like, let this new class be inheriting the state and behavior from the first class we created early on. In that case, the former will be called a parent class and the latter will be called a child class. The relationships between them will be defined as is a relationship. So class 1 is a parent of class 2, or class 2 is a child of class 1. So for our example, let's define another class, well, called car. And I've copied the init method from our previous example. I'll just take this purchase thing off, and let's define another class, and we'll call it forklift. So of course this class will need init method as well. So the way init method looks at the moment is not the way we want it, thanks to the autocomplete in VS Code. So we need to modify it. We want maker, model, color, and price. And we're going to add another parameter, which is lifting weight. Well, because it's a forklift. And we'll need to fill the body of that method as well. I'll just copy that over and I'll add the lifting weight. So these are 2 classes that we will work with. We will expand on that topic. And let's copy the whole of the forklift class and paste it down below. So we'll define another class, say that's going to be called crane, and I mean auto crane. And what's important is that those 2 classes, say forklift and crane, as in auto crane sense, they are both, well, some sort of a vehicles. So they all have maker, model, color, price, and they can lift some weight. You can basically notice 2 things. First is that class car is not much different from forklift and crane. In fact, it is the same class but without the lifting weight attribute, and that there are plenty of attributes just being repeated. And as you probably know, repeating the same code is not a very good idea. So first of all, let's deal with the first issue and add a new attribute to the init method, which is going to be the number of seats. Therefore, we will at least have 1 unique attribute for the car. And in order to address the second issue, we can use the inheritance. So first of all, let's define a new class called vehicle. That will be, say, a parent of all classes, car, forklift, and crane. Let's define init method. Thanks for the autocomplete. Basically, we'll just copy and paste that from class car. So I will define the same stuff, self, maker, model, color, and price. And I will copy and paste the rest. All right, so now we have these attributes in class vehicle, and we don't really need them in class car. So as I've said, we don't really want to repeat ourselves, repeat the code. Therefore, we can use the inheritance mechanism in order to address that. So let me get rid of all these attributes, and instead we will type the following. To sort of point to the parent class the class will inherit from, we use the keyword super, so that vehicle is the super class of class car. Here we're basically saying that we will inherit the init method from the class vehicle. In other words, we'll just copy the attributes of init method from our parent class. Once again, this construction allows us to say that the maker, model, color, and price will be copied directly from our parent class, vehicle, and we need to put vehicle inside the brackets as well in the car class to specify that this is our parent class. And also, car class will have its own attribute which is not present in its parent class, called the seats, which corresponds to the number of seats. And let's create another class. We'll call it something like industrial vehicles. And this will be a parent class of forklift and crane. So essentially, we're going to have the following schema. Class vehicle is the parent class of all classes present in this file. Then class car inherits directly from class vehicle. Class industrial vehicle inherits directly from vehicle as well. And forklift and crane will inherit from industrial vehicle, and therefore the vehicle itself is going to be like the parent of its parent, if you'd like. So once again, we have a lot of redundant code. Therefore, we can use the inheritance mechanism once again. The forklift and crane will be inheriting from industrial vehicle. Therefore, they can use all of its attributes. And now that I've specified that forklift and crane inherits from industrial vehicle and that industrial vehicle inherits from vehicle, I can get rid of that redundant code. So let's start with the industrial vehicle first. So they can be replaced by super and pointer, if you'd like, to the init method of the parent class. And we need to copy them into the init method as well. All right, so now the only unique attribute we've got left is the lifting weight, which is defined first in the industrial vehicle. And now we'll do the same with forklift. So we're going to replace all those attributes with a super, but this super will be pointing at the industrial vehicle. So the class it is inheriting directly from. And we'll do the same for the crane. I will just copy and paste forklift's init methods into crane, and that shall do the trick. So once again, class car inherits from vehicle, class industrial vehicle inherits from vehicle, and forklift and crane inherit from industrial vehicle. All right, we are ready to create the instances of these classes and see how they work together. All right, so our first object will be called car1. It will be an instance of the car class, and as the maker, I'll come up with something like Opel, and as the model, Mocha, and color black, and the price will be an integer. So we won't need the quotes. Let me get rid of them. So 20,000 units of money of some sort. All right, so let's do another one. Forklift. So forklift 1 is an instance of the class forklift. Once again, the maker, I'm not sure, Honda, I think they do forklifts. Model, I definitely have to look it up, or just make something up. It doesn't matter, it's like a placeholder value. We need to illustrate the point. So the color will be brown, and money, the price will be 15,000. Next one is crane 1, and it's going to be an instance of a class crane, of course. And who makes cranes? Caterpillar. And the model, let's say this, and then the color, of course, yellow, and it's going to have some hefty price. All right, we also forgot about another attribute, the weight it can lift. So let's say it's going to be in tons, and for the forklift it's going to be 5, and for the crane it's going to be 55. Very nice. 55 might be a little bit too much, so let's make it 15 because it's an auto crane. And now let's try to print them out. So the first print statement, car 1, the other one forklift 1, and the last one will be crane 1. I'll explain in a second why we put them in a separate print statements, because basically if we're gonna launch the program execution now, we're gonna be given just the address in a memory for this object, but we want to print some attributes. Therefore, we're going to use the dot operator to access those attributes. So you're going to have car1 maker, car1 model, car1 color, car1 price, and we also need seats. I forgot the seats, so car1 seats. I'll speed up in here so you won't be too bored me typing. So we're almost done. And let's try to launch it. And we run into an error, attribute error. Crane object has no attribute maker. This is because I've done the copy paste and I've probably missed a bit of code. So let me correct that. Let me copy and paste that again. All right, that will do. Yes, you can now see how by utilizing the inheritance mechanism, we have reused a lot of code. Otherwise, that will be redundant. But there was one slight problem. Nothing would have stopped us if we would want to create an instance of a class vehicle or industrial vehicle. Nevertheless, they are more or less abstractions. So conceptually, they are more of a blueprint from which we create cars and forklifts and whatnot. So there is a programming concept called the abstract class. So the class, which is, surprise, surprise, abstract, and we cannot create a direct instance of that abstract class. So let me show you how this concept works in Python. So here we create a class called electrical appliance, and it's going to have init method, of course. I'll just get rid of this autocomplete, and we'll immediately define that it inherits from some other class. It may not be apparent which class it inherits from or why we need to do that straight away, but it will make itself clear once we define other classes and methods. So we write something like super.init, and let's say down below we'll define another method which is something that is common among all electrical appliances, something like, I don't know, power. Well, maybe not power, but let's say electrical consumption. So all electrical appliances will have their own rate of electrical consumption. And for now, we'll leave it empty. The idea is that the classes will define below, let's say class heater, that will be inheriting from electrical appliances. So these classes will need to implement this method by themselves according to the idea behind their classes. So one of the classes is called heater, so it will be, well, heating. So I need to specify this attribute, heating, and I need to add it here as well. All right, that's done. And the next class will be called cooler, and it will inherit from the electrical appliance class as well. And instead of heating, it will be, surprise, surprise, cooling. So we'll specify it here. We need to also specify that it inherits from the electrical appliance class. So that's cooling. We'll get rid of this boilerplate code. Right here. All right. As you can see, the electricity consumption method is not implemented in any of the classes that inherit from electrical appliance. And we can happily get away with that because there is no mechanics that could force us to implement this method at the moment. And also, nothing prevents us from creating an instance of the electrical appliance class. Nevertheless, conceptually, it is an abstraction. So in here, we'll create an instance of a class heater and instance of a class cooler. And up here, we'll define, here is instance of a class electrical appliance, the instance of our abstraction class. Of course, we need to specify an attribute. In case of the heater, it will be some heating units, so probably degrees, 50 units of temperature, and cooler is 20 units of temperature, and then we'll print them out. Despite that, it will only give us the addresses of these objects in the memory. We just wanted to prove the point that nothing prevents us from running the code as is. So in order to enforce this mechanic that the electrical appliance class is an abstract class and we cannot create a direct instance of this class, and electricity consumption is an abstract method and we need to implement it, we will import something from the standard library, the module called ABC, so abstract base class, which will basically allow us to enforce this mechanic. So from ABC, we import ABC and abstract method. And now in the electrical appliance class, we put that it inherits from the abstract base class. And now this super statement makes sense. Same for the electricity consumption, put self and abstract method. And if we'll run the code now, we're going to get into an error. So can't instantiate abstract class. So we need to get rid of that E, instance of the electrical appliance class. And we also must implement this electricity consumption method. So let's deal with it first. So in class heater, I'm defining the electricity consumption, and let's make sure it's doing something useful. So when we create an instance of the heater or cooler class, we pass a value. In case of heater, it's 50. So let's assume that to heat a room for 1 degree, this heater consumes 1,500 of units of something, maybe power or something else. And we will multiply this by the value that is being passed when we create an instance of that class. So in this case, by 50. I'm not trying to do something meaningful here. I'm just trying to prove the concept, abstract classes and methods in this case. So let me jump to the cooler and implement that method before I forget. So you will multiply, let's say, the consumption equals to, I don't know, 300, and it will multiply it by the value that is passed when we create an instance of a cooler. So we multiply it by the attribute cooling and self. I need to get back to the heater, and we'll multiply it by self.heating. All right, so at least it is shaping into something meaningful, and we can even try to run the code. So we have heater, we have cooler. Let's try to run it, and we run into another error immediately, which is basically the same error. I just forgot to remove the creation of the instance of an abstract class. So we need to comment that out. As you can see, no errors. But what if we would like not the addresses in memory, but the actual heating and cooling values? So we need to use the dot operator, and we do h dot, and what we need is heating, and case of cooler is cooling. And let's also utilize the method electricity consumption. So it's going to print the electricity consumption for the heater and for the cooler. And of course, because this is a method, not an attribute, we need the brackets. Okay, so we have the value for the heater, and then this value get multiplied by 1,000, and we get the electricity consumption. Same mechanics works for the cooler. Okay, so this was a brief overview of how the abstract classes and abstract methods work in Python. Next, we'll look into the multiple inheritance. So the inheritance we looked at so far sometimes is referred to as the linear inheritance, is basically where we had a class vehicle, then it was inherited by class industrial vehicle, and then it was inherited by forklift and the other one, the crane. But this is sort of one line of inheritance. Multiple inheritance is when we have several classes at the same level and another class that inherits from both of them. Multiple inheritance is not allowed in some languages like Java, but Python is not the case. In our example, a class called child will inherit traits from both classes parent 1 and parent 2. So let's say parent 1 will have an attribute smart and parent 2 will have an attribute pretty. So let me sort all that. So the multiple inheritance is not tremendously complicated concept to understand. And as I've mentioned before, it's not quite natural for other languages like Java, for example, which forbids multiple inheritance completely. But here in Python, it works pretty well. So we define two classes, parent1 and parent2, with two distinct traits for smart and pretty, and class child inherits from both parent1 and parent2. Therefore, it does not need to define those traits, those attributes inside the child class. It can only do effectively pointers to its parent classes. So if I'll print the self.pretty and self.smart, it will pull the values for them from the parent classes it inherits from. And down below, I'll create an instance of the class child, and then I will access the traits. So I'll do that via the dot operator, child.traits, and we'll, of course, need to print that, pretty and smart. Right, so it works nicely, but what if we have not distinct traits or distinct attributes, but what if both parent classes contain the attribute with the same name? So which one gets inherited? Let's say, for example, that the parent one has got an attribute hair color, and it will contain the value, let's say, light, and parent 2 will have a dark hair color. In this case, both parents have an attribute with the same name, but different values. So child will inherit hair color as well, but the question is which one? And this is where something called the method resolution order comes into play. So here we specify the order of inheritance as parent 1, then parent 2. So parent 1 has light hair color, therefore it gets inherited by the child. Well, if we'll swap them around, let's say parent 2 will get the prevalence over parent 1 in the inheritance order, then the child will inherit whatever parent 2 has got as an attribute value. So in this case, it's going to be hair color equals dark. So let me illustrate that by just swapping them around. So I'll select parent 1 in the child class. I'll cut it and I'll paste it behind parent 2. Of course, don't forget the comma. All right, and now let's see the result. In this case, parent 2 was given the top priority over parent 1. So now you can see the hair color has got value dark. As I've mentioned, it's not a terribly complicated concept. So the next concept we're going to look at is how we define interfaces in Python. So just as a reminder, at a high level, an interface acts like a blueprint for designing classes. They are somewhat similar to the abstract classes, but with a key difference that in interface, you only define the method, you cannot implement it. So the class that inherits or rather extends the interface will need to implement that method. I would highly recommend to look up the definition in the docs. All right, so here, as you can see, we define a class called shipping, which inherits from the abstract base class. So the interfaces are in a sense resolved via the abstraction, and we defined a method inside of that abstract class and use a decorator to mark it as abstract method. And here down below in heater class, we can define under the method shipping. So the heater class will extend the interface shipping and will need to implement the method from the interface. You can get this code from the Ave Coders repository. I'll leave the link in the description below. So the class heater has implemented the method from the interface shipping, and in here, as you can see, where we create the instance of the class heater, we need to specify the shipping type as well. So in this case, I'll use the cargo ship. And we finally got the updated result. Once again, not too complicated concept as well. All right, let's have a look at the composition. Composition is a fundamental concept in object-oriented programming, or OOP, that allows creating complex objects by combining simpler objects. In other words, composition is a way of creating complex objects from simple ones. In Python, composition is achieved by using instance variables that are objects. A music band is a perfect example of how composition can be used in OOP. A music band is made up of different musicians, each playing a specific instrument. We can represent this structure in Python using classes and instances of those classes. Let's start by defining a simple class, musician, that represents a musician in the band. Next, let's define a class band that represents a music band and uses the musician class. The band class has two instance variables, name and members. The members variable is a list of musician instances representing the musicians in the band. The play music method returns a list of strings that describe each musician playing their instrument. Finally, let's create an instance of the band class and see how it uses the musician class to represent a music band. This code creates 4 instances of the musician class, each representing a different musician in the band. It then creates an instance of the band class, representing the music band, let's say the Beatles. Finally, it calls the play music method on the Beatles object and prints the result, which is a list of strings describing each musician playing their instrument. This is a simple example of how composition can be used in OOP. By combining instances of the musician class, we can create a complex object, the band class, that represents a music band. There are several benefits of using composition in OOP, including reusability. So reusing existing objects to create new objects is a key principle of OOP. By using composition, we can leverage the functionality of existing classes and use them as building blocks to create more complex objects. Flexibility. Composition allows us to easily modify the behavior of a complex object by changing the objects it is composed of. This makes it easier to maintain and update our code, since changes can be made at a granular level. Abstraction. Composition can help us achieve abstraction by encapsulating the details of the individual objects and presenting a higher-level view of the composite object. This makes the code easier to understand and maintain. Code organization. Composition helps us organize our code into smaller, reusable parts. This makes it easier to understand the code and helps reduce the risk of bugs and errors. Improved testing. By using composition, we can create smaller, more focused objects that are easier to test. This makes it easier to ensure that the code is working correctly and reduces the risk of bugs and errors. Here are some tips for using composition effectively in OOP. First of all, keep it simple. Avoid creating overly complex objects by composition. If a composite object is too complex, it can become difficult to understand and maintain. Basically, you can use composition to encapsulate the details of individual objects and present a higher level view of the composite object. For example, use composition to represent the relationship between a music band and its musicians.
Avoid creating circle dependencies between objects by composition. This can lead to confusion and make it difficult to understand the code. Use composition in combination with inheritance. Composition and inheritance are often used together in OP. Use inheritance to create a hierarchy of classes and use composition to create relationships between objects. In conclusion, composition is a powerful concept in OOP that allows creating complex objects by combining simpler objects. By using composition, we can achieve reusability, flexibility, abstraction, code organization, and improved testing. When using composition, though, it's important to keep it simple. Use it to create abstractions, model real-world relationships, avoid creating circle dependencies, and use it in combination with inheritance.
Alright, I'm going to be using VS Code with the Python extension, and I'll build on what we've done in the OOP lesson. So if you haven't seen it, so go and watch it first, so to understand what's going on. Alright, so the first magic method is called str and is basically responsible for string representation of our object. Please pay attention at the double underscores, prefixing and postfixing the method's name. And if before, as you remember, if we would instantiate the object of that class and would attempt to print it, we would just get an address of that object in memory. However, if we'll do the similar operation now after overriding the str magic method, we will get a nice human readable representation of that object. So let's have a look. So car1 is an instance of the car class and is going to be Toyota, let's say Camry, and we're going to define the price as integer, something like 7,000 units of money. And also for comparison, we'll instantiate a new object of car2 of a class car, which is going to be Opel Mokka, and it's going to cost us 14,000 units of money. And let's do a bit of an experiment first and comment out the str, just to remind ourselves how the representation of the object looks like without this magic method. We can't see anything because we haven't used the function print. Okay, so let's print car1 and car2 and have a look. So we'll get just an address of that object in memory. Not that nice. And now let's see what's going to happen when we'll uncomment the str magic method and run it again. So as you can see, we get a nice string representation of the object's attributes, which is the name, the Toyota, then the cost. All right, so this was our first magic method, str, but there's another one. It is called a wrapper, and it is responsible for string representation of objects' attributes as well. The difference? Well, according to the official documentation, wrapper is used to compute the official string representation of an object and is typically used for debugging. And if you want to learn more about the intricacies of this magic method and the difference between str and wrapper, I will advise you to head to the official documentation and have some fun there. We'll observe the effect and some use cases for these magic methods on our object. And we can actually call these methods when we invoke the wrapper and str functions on the object. Str for car1 and wrapper for car2. And as you'll see, the output doesn't look too different. Now, it's not only about this human readable representation. Let's have a look at the comparison, for instance. Let's say car1 and car2 will be compared using the double equal sign. So we can see that the car1 and car2 are two distinct objects, but we can just look at their attributes and see that they are slightly different. They have different values. And if we'll compare them using the double equals, then we will rightfully receive a false. But as we see, car2 and car3 are two similar objects. So if we'll compare them, they do have the same values actually. Opel Mokka and the price is the same, but we also get false. Why is that? Well, this is because it compares the objects as their addresses in memory. It doesn't compare their representations. So we need another method called EQ for equals or equality to make sure we can compare two objects. And inside this method, we need to specify which values are we going to compare. So in this case, it's going to be make, model, and the price, so that it will at least know the criteria for comparison. In this case, a value argument represents the object we are going to compare the first object with. So it will sequentially compare make, model, and price of two objects. We also use the AND keyword to unify all these statements. And it will also be helpful if we'll add some kind of a conditional here saying that if the instance of the method we will compare with is not a car class, then we will not compare them. We will raise value error because we can't really compare something that is not of the same class. So we're going to print can't compare because of the type mismatch. And this is a logical thing to do because if we will be comparing, say, a car and a music instrument, then it will make no sense. So now, if we look at the result of comparison of car2 and car3 via the double equal sign, then we will receive true because essentially car2 and car3 confirmed they are the same entity. And of course, the comparison of two separate entities will still return false, but this time the interpreter goes into what values do their attributes hold instead of just comparing their addresses in memory. So this is how we compare basically whether the two instances of the same class have the same values as the arguments. But how do we compare that something is, say, bigger than something else or smaller? And luckily, there is a magic method for each of these cases as well. Actually, there are more than what we're going to show in this lesson, but please feel free to check out the docs. I can't see any sense to, showing them all here. So I'm only going to show you two of them. First one is more than or equal to, and the second one is less than. However, here is the question. How would you compare what is bigger, Opel or Opel? You need to know some kind of a numerical, let's say, metric. And in our case, the only metric here is the price. So if your class would have, for instance, many more attributes, you can add, I don't know, the engine capacity or the engine power. But in our case, we do have a pretty simple class, so we only going to compare them by the price. So the magic method for comparing what is greater than or equal to is GE. And we're going to put this check here as well so that we compare two instances of the same class. And down below, we're going to specify which attribute we're going to use in our comparison. So in our case, it's going to be, of course, the price as the only numeric attribute. So return self.price is greater than or equal to value.price. All right, so that was greater than or equal to method. So now we're going to do the less than method. Somewhat expected, the method that opens this functionality to define which instance of the class is less than or just less than. The other one is called LT for less than. And once again, we pass self and value, and we do the check, making sure we compare two instances of the same class. And similar to the previous method, we only return self.price less than value.price. Self.price is less than value.price. All right, so let's try to run them. And we have attribute error. Of course, it's not print, it's price. All right, so now you might be asking, that's all neat, but how can you use that in real life? What is the practical applicability of these methods? Well, what it actually gives us is the ability to compare objects. So now we can, let's say, we can make a list of some objects. I'll comment them out. So let's imagine we are running some car dealership. So we have some cars. I'll represent them in a list. So car 1, car 2, and car 3. And for the sake of this example, let me change the car 3 slightly. So let me go to the car 3 and I'll swap Opel for some other value. Let's say it's going to be some unknown maker. And it's going to be, I don't know, junk wagon. And it's going to be just a few bucks. And let's say someone wants to see the offers cataloged by, let's say, price from lowest to highest, which you can normally do on any decent car dealer website. I'm not saying that it works exactly this way, but at least you got the point how we can use that. So we use sorting, and then we're going to print the sorted list of cars. So the cheapest first, and we're going to iterate by this list and print cars by makers. So in other words, we'll not display the price, we'll just display the not the makers, doesn't make sense, let's say model. And if we'll run the code now, we're going to see sorted list, and junk wagon comes first, then Camry, and then Mocha. Press the like button if you have ever had any of these cars. All right, so these were two of these comparison methods. By the way, there are many more of these type of methods, as well as some math as well. You can check out the documentation if you want to learn more. But we'll move on, and the next topic I want to talk about is the topic of control. What magic methods also allow us to do is to specify how the attributes are going to be accessed. In other words, inside of a class, we can specify these interception methods. And every time we'll want, for example, get the attribute or set the attribute, it will specify the behavior. So in this case, we will start with the get attribute method. That will essentially allow us to manipulate the value of the attribute price before we'll return it. Let's say in this example, we want to apply the discounts to the price. And we want to do that automatically every time the value of the attribute's price is retrieved. So the first line, if name double equals price, makes sure that indeed the price attribute was accessed. But here's the thing, because we are already inside the method that is going to get called every time the attribute is going to get accessed, if we will simply refer to the object's attribute by its name, then we'll get stuck in an infinite loop until the program will crash. So we can escape that by calling the parent of getAttribute method with the price and discount. And we'll store the returned values in variables p for price and d for discount. And in the end, we'll perform the math, and this will make sure that every time we access the price attribute, we get a discount. But we also need to specify what's going to happen if the attribute that was accessed is not actually price. So we just return the name of the attribute. So once again, the parent of get attribute with the name. All right, so down here, we'll start to manipulate our price. And let's say we offer to swap the old car for a new car, or for a discount to buy a new car. I'd say it's a fair deal. So we're going to access the attribute price on car 1 via the dot operator, and we're going to set it to 7,500 units of money. And then we'll just print the car 1. That will trigger the str magic method, so we'll get a nice human readable representation of our object car 1, which is, we need to comment that out. And we can see that it is Toyota Camry that costs now, the discount was applied, so 5,625. Nice. All right, so this is how we get the attribute, but we can also set the attribute as well. There is another magic method responsible for setting the attribute, and it is called surprise, surprise, set attribute. So let's move back to our car class, and just down below the get attribute, we'll specify the set attribute. But this time the name is going to be a little bit shorter, so it's set attr instead of attribute. And let's code the behavior so that when someone is setting the, let's say, price value, we must have it in float. So we do a condition here as well. So if name equals price, making sure we are modifying the right attribute. And here we check the type of the value of that attribute. And if it's not float, we raise the value error saying like price must be float. And once again, if the attribute is not price, we will just return the name of that attribute. So we'll access the parent of set attr, so super set attr, and the name and the value of non-price attribute. All right, so down below, let's try to modify this line. Actually, let's try to run it first and see if we can get the error. Yes, we have an error, value error, price must be float. So if we'll modify the value to something like 7,550, which is a float, but we still get the error. And this is because at the top where we initialize the object, we specify the price as an integer. Now that I've commented them out, I will reprint the object creation down below. Let's say we want the same Toyota Camry, but this time the price will be not the integer, but it's going to be of type float. So I'm going to add, let's run the integer first, we get the error. And now if I'll modify the price and I'll add a 0.50 to make it float, we get everything working. There is another way we can specify that the value is actually float, is to cast it to the float. So this will work as well. And not only we specified the value for the price attribute via the set attribute method, we also get a discount on that price via the get attribute. However, if we'll try to access an attribute that doesn't exist, let's say engine, we're going to get the attribute error that car object has no attribute engine. And as you might guess, there is another magic method to handle these situations. Its name is a shorter version of getAttribute method known as getUtter. So this method gets called in one of the following situations. Either when getAttribute method does not exist, or it raises an error, or when we try to access an argument that doesn't exist in this particular class. So it will just return the name of the attribute and a message that this is not implemented, and that should be enough. So engine not implemented, we'll just have to maintain a space. So the attribute engine is not implemented. And another handy and yet pretty straightforward method we will look at is called call. In short, what it does is it enables Python objects to be called like regular methods. All right, so let's go over here and we'll specify this magic method call, which can take either the variable number of arguments, that is what autocomplete is trying to convince us to do, or it can take or replicate the arguments that exist in the init method. This is what we're going to implement for this example, which means that we can use some of the copy and paste magic and just copy these arguments into the body of that method. And down below, we're going to look at a few examples of what we can actually do with objects in Python. So as you know, car1, the very first line is the standard implementation of this car class we had a look at previously. And then we print this engine, which will comment out. But then what I'm typing now is actually a tuple. So in other words, car1 will now contain a tuple. And the behavior is going to be as if we would work with tuple. So let's launch it. We need to change the print statement. So we'll just print the car1. And I'll copy that statement and paste it underneath the tuple. So print car1, and you'll see the difference. So the first statement is the values of arguments of the genuine instance of the class car, and the second statement, these are just the values in the tuple. But this representation might be deceptive because it does looks like the values of arguments of the instance of a class car, but it is something totally different. But what the call magic method actually allows us to do is we're going to use it right now. We're going to actually call the instance of that car1 of the class car as a simple function. So in this case, I'm going to do car1, and let's say it's going to be Porsche, Carrera, and some money. And this is, of course, needs to be float because we have a setUtter method that checks on that condition. We're going to copy that print statement as well. And actually, when we'll try to run it, we'll get into an error. Thanks to the tuple conversion, car1 is no longer an instance of a class car. So it's going to error that the car1 is now a tuple, and tuple is not callable. So this is how dangerous and deceptive the reliance on just the print statements might be, because, as I've said, they do look similar. I mean, the representation of the values of the car1 as an object and then as a tuple. So we're gonna comment them out. The car1 as the tuple, we don't want that anymore, so we'll comment that out. Just a handy tip in case you didn't know, so you can actually select the lines you want to comment out and then press Ctrl and /. And now, as you can see, it works as it should. And just before we'll wrap up, I'll show you another trick, which is not really a magic method, but it's still very handy. But before that, I'll remind you that the code from this lesson is available in Ave Coders GitHub repo. So our next guest is not really a magic method, but rather it is an attribute of a class written with the double underscores as well. So it dict, and it contains the dynamic attributes of an object. So if you want to, let's say, use it with a car1 and then by the dot operator call dict, so it will print the attributes with their corresponding values, which may be a really helpful tip. All right, so starting from Python 3.7, we can create something that's called data class. But first, let's remind ourselves how a regular Python class looks like. So I've just copied this one from the lesson on magic methods. If you haven't seen it yet, I would recommend you to go and see it. The link is in the description. But meanwhile, I'm gonna import the data class from the Dataclasses module, and I will write a decorator data class. All right, so now that the Python interpreter knows that this is a data class, we can start changing it. So first we got rid of this init method. Then we can get rid of self. And since now we have those redundant values, as in make equals make, model equals model, we can start getting rid of them and just specify the type. Now, this is not a strict type. This is more of a guideline for us, the developers, and the interpreter, what to expect. And yes, the first impression might be like these are class attributes, not instance attributes. But this is what the data class decorator is there for. And what's going to happen under the hood is that this class will be generally rewritten with the init function. And once we will initialize the object, these attributes will be initialized on the object instance as normal. For example, here we define car1, which is an instance of a class car, defined with the following values. So make is BMW, Mini Cooper is the model, surprise, surprise, and price is 27,085 units of money. Then we print it. And surprisingly, instead of the address in the memory where this object is stored, we will get an actual representation of these objects with the values of its attributes. And as you can see, we have a nice representation of the car1 object, because in data class, the wrapper magic method is implemented by default. If you got no idea what am I talking about, go check out the video on magic methods. All right. Another method that is implemented by default is called EQ, so equals. In general, it allows us to compare or check whether two objects are equal to each other, as in they have the same values of their attributes, and the number and the name of the attributes are the same as well. So now we can compare car1 and car2, two distinct objects, with the double equal sign, and we can check whether they equal or not, and of course it returns false. But without the EQ magic method, it returns false regardless, because it only compares the addresses in memory, and of course they will be different. And now if I will create a copy of car1, car3, and I'll compare them two, then I will get true, because indeed the number of attributes, their order, and their values are the same. However, despite all these cool bells and whistles, this is a regular class. So we can define a method within this class. Let's say it's going to be a promo of some sort. So let's say when it is called, it will return a formatted string where it will represent the make, the model, and the price. So let's say return then f and self.make. Actually, let's make it a proper promotion. So I'm going to say something like self.model. So this model by this manufacturer, and it's going to be for just and then the price. So let's give us some space for the manipulation of this method later on. So just a regular method promo, and now we can call this method via the dot operator on our object. So I'm going to comment that out, and I'm going to say something like print. It doesn't matter which car, so car1 dot promo. And of course, because this is a method, don't forget to put the brackets. And that, of course, returns what we would expect, Mini Cooper by BMW for just 27, whatever the price. But you might be asking yourself, all right, then if the init function is pretty much hidden under the hood of data class mechanics, then how can we implement a certain behavior when we, say, initiate an object? And for this reason, we have a special method which is called the post init. And so this function will be called when the built-in init method will finish. So let's transform our car class. We're going to define this post init function, and we're going to cut and paste parts of the promo method to that function. So let's do that. I'll make sure promo is not it's not a method anymore. So let's say every time upon the initialization of the object of a class car, we're going to be getting this string. So now the promo is not a method anymore. We need to get rid of the brackets. And now you can see the same result, but with the post init function. Another cool thing about data classes is that we can define some default values for the attributes. So for example, I can define a default make, default model, and default price. And even if I will create an instance of a class car without defining any of these values, I will still get an object with these default values. So for example, make will be, let's just transfer all those values to the default. So BMW, Mini Cooper, and the price is 27 something. And of course, later on, we can extend this mechanics a little bit, because hard coding these values might not be as cool as, say, having a randomizer defining the price. But we'll do it right after I'll show you the mechanics, how it works in general. So let's say I will comment everything out, and I will define a new object. Let's say it's going to be car0, just for the sake of the example, and it equals car. So here we don't specify any values. Nevertheless, if I'll print car0, I will get BMW, Mini Cooper, and the price. How cool is that? But I think what can be even cooler is if we will define this price via some kind of a dynamic behavior, let's say a randomizer. And Dataclasses module allows us to do that as well. All we need to do is we need to import something called field. So this function will allow us to sort of extend the mechanics of this, if you'd like, fields in the class. So we can replace the price with the field function, and it has some arguments here as well. We'll specify the default factory, and we'll make it equal to the method, which we will define as well in a second. So price gen. So in essence, how it works is that the default factory will be called when a default value is needed for this field, and the value will be supplied by the function called priceGen. This is essentially a randomizer where we'll generate a price within a certain range. So we'll specify the range via the rand range, and we'll make it from, let's say, 20,000 to 30,000 units of money. And basically what's going to happen now is that every time we instantiate car0 object and print it, so every time we call the function print, we're going to get a different value for the default price, which is kind of cool. Well, not really cool, but at least is not as straightforward as a hard-coded version. All right. Another important point I want to make is that now nothing prevents us from changing those default values. In other words, we can redefine them in each new object we create, and Python will not stop us from doing so. So I'm going to illustrate that with a car4 object, which is an object of a class car. And once again, I'm going to define, or let's say redefine, the default values for, let's say, car4.make. And if I defined make as currently is BMW, but if I'll define it as, say, Renault, I can easily do that, and I will not get into any type of error for doing that. So down below, I'm defining car4.make, and I write something like Renault or Renault. And I'm going to copy that print statement and paste it down below so we can see the difference. And as you can see, BMW was swapped to Renault. But what if we want to change the standard behavior and prevent it from happening? Well, all we need to do is to switch the argument of the data class decorator from false to true. And this argument is called frozen. So if we'll set up to true, because it is set to false by default, so if we'll run the code now, we'll get into an error. And in particular, it is frozen instance error. It says we cannot assign to field promo. So in this case, it caught up on the assignment to the promo, but it is generally will not allow us to do any business with any instance arguments as well. And just to give you another example, so let's say we'll define a new method, and it is a class method, so it will, same as post init, it will try to change the value or reassign the value for one of the arguments from within the class. So let's say it's going to take promo value, and it's going to set up price equal to this promo value. So I'm going to specify self.price equals promo value. Okay, so let's make it consistent. So let's say promo price. So self.price equals promo price. And let's try to launch the code now, and we should get another error, which is basically the same error. We cannot reassign any of the values. So let's comment that out to make sure I've commented something I shouldn't comment out. Comment out. All right. That should work. Just to make sure we definitely understand what kind of method has caused the error. So we're going to call new promo, and we're going to pass the value of 20,050, let's say. All right, and as expected, we get this same error. This was an introduction to data classes. I would recommend you to check them out in the official documentation. As the official documentation tells us, an enumeration or enum is a set of symbolic names bound to unique constant values. Within an enumeration, the members can be compared by identity and the enumeration itself can be iterated over. So that's all good. Let's crack on with them. First of all, let's import enum from the enum module. And now we can use the mechanics in our code. First of all, I will create a class called car. That will inherit from this enum superclass, and this is how we can apply the enum mechanics to this class. So let's define a few constants within this class, all caps. It's going to be Opel with the value 1, BMW with value 2, and Mercedes with the value 3. As soon as I'll learn how to write Mercedes properly, make it 3. All right. Let's have just one more, which is going to be Porsche, number 4. And now let's have a look at the enum mechanics. So we're going to go into the main function, remove the pass, and now, first of all, let's print the one of the enums, so car Opel. So we're using the dot operator, and after that, we can also print the type of that enum. So we use the function type and we put car.opel as an argument. And we can also pass it as the wrapper function argument as well. So let's leave Opel as it is. And here I'll change type to wrapper. If you don't know what that is, go and check my tutorial on magic methods. I'll leave the link in the description. But as you can see, here we get a series of outputs, car Opel, then the type is of course enum, and then the enum name with the value. All right, let's move on. And another interesting rule about enums is that you can't have two enums with the same name. However, you can have the same value. So let's say BMW, and I'll put the value 2. And if we'll run it, we'll get into an error. Attempted to reuse key BMW. Key is hence a name. So it wasn't triggered by the value, it was triggered by the name. And if I'll change BMW to Renault, we can see that we get no error. However, if we don't like that we can have duplicates as values, we can also enforce a different behavior. We can import something called unique. And in here, we can use the decorator unique. And now if we run it, we'll get into an error. So duplicate values found in enum car. So Renault and BMW do have the same value. However, in case when we use the consequent values, so let's say 1, 2, 3, 4, and then we want 5, we can use something called auto. So auto instead will substitute the next subsequent unique value for us. So if we'll change the value of Renault to this auto, so now if I'll print car.Renault and then name, so as you can infer probably from this key value situations, the enums do have keys and values, so we can print them separately if we want to, like in this case. So name is Renault and value is 5, because auto has substituted itself with the next subsequent unique value. Ave Coders, and welcome to the crash course on Python and SQLite, where we'll learn the basic CRUD operations, such as we'll learn to create the database, read the data from the database, insert the data into the database, update the data, and finally delete the data. Now, the SQLite is a fantastic database for the beginners because it is generally an embedded database, not a client-server database, which means that we don't need to spin up a separate server for it. Rather, we'll just import the SQLite 3 module and interact with the database via some simple function calls. But first, let's create a virtual environment. So how do we create a virtual environment? Well, first of all, we pip install virtual env. And now we need to create our virtual environment. So we write the following script, python -m vnv, and then the name of our virtual environment. In my case, it will be SQLite workspace. And after running this script in the working directory, you'll notice a new folder, SQLite workspace. Now let's cd into our virtual environment and activate it. Now, if you are on Linux or Mac, all you need to do is write source and then bin and activate. But if you are on Windows like myself, all you need to write is scripts and activate with a backslashes, of course. And if you'll see in the terminal the name of our virtual environment, that means that we have successfully activated and now we are working from within our virtual environment. All right, let's create our Python file. We'll call it SQLite products.py. And at the top of the file, we import SQLite 3 module. And this SQLite 3 module gives us the tools to interact with the database. Let's begin our interactions by establishing a connection via the method called connect. Inside of this method, we need to specify the name of our database. In our case, it will be something like products SQLite.db. So not only this method will establish the connection, but also if our database doesn't exist yet, like in our case, it will create the database for us. But after we run the script, we notice that nothing happens. This is because we need to supply several other methods to make this operation successful. So after we save our connection into this object connection, we can call another method called commit. The mechanics is pretty much similar to Git, where this commit method just commits all transactions that we have built up to this point. And then, of course, we need to close the connection. After running the script, you can notice that our database was created, and you can observe it now in the working directory. All right, now that we're all set up, let's clear some space. And first things first, let's introduce a cursor. So in essence, the cursor is a mechanism that enables us to traverse over the records in our database. So we call the cursor method on our connection object and we save the result into the new object called cursor. And then we can use another method called execute on this cursor object to pretty much interact with our database via the SQL requests. So basically this execute method is responsible for executing the SQL queries. Let's use it to create a table in our database. So I'm using the triple apostrophes or quotes because we'll have a multi-line SQL query. So we say create table if not exist. So if the table doesn't exist yet, the name of the table is products. So which fields are we going to specify for our table? Well, first of all, it's going to be the product ID and it's going to be of the type integer. Product ID also is going to be our primary key, and we also want it to auto increment as we add more records. Another field will contain the name of the product we are listing. So it's going to be of the type text, which is roughly equivalent to the Python data type string. The next field is the name of the supplier who supposedly supplying us with this product, and it's going to be of the type text as well. And finally, the price per ton, and it's going to be of the type int. So this type int will be casted into an integer, but for the primary key, this would not work. So we would need to specify integer as the whole word. All right, so we have created our schema, but there's nothing there in our table just yet. So if we'll execute the select all statement, it will return nothing. So inside of this execute method, we write a select star from products statement, and as I'm launching the script, nothing really happens. And just to confirm that, I will write a print statement, and inside the print statement, I'll write cursor and fetch all. And when I run it, you see nothing is returned. So let's populate our table. So let's move our select from statement a bit further down and clear some space and define the products we want to insert into our table. So let's say for this training example, we'll only have 3 products. And let's imagine that we are running a wholesale fruit company of some sort. So the first product will be bananas, and the supplier will be United Bananas, and it will cost 7,000 of money. The next one is avocados, United Avocados as a supplier, and let's say 12,000 for them. And the last one is tomatoes, United Tomatoes, and the price is slightly lower, 3,100. Now, since essentially we have multiple objects that we're going to turn into multiple records, instead of cursor.execute, we need to use cursor.execute many. And inside of this multi-line SQL query, we're going to specify that we want to insert. Then where to we want to insert, so into our table products. Then we need to list the fields we will populate, such as product, supplier, and price per ton. And then on the new line, we're going to use the keyword values. And essentially, we're going to be using the placeholder mechanism. So we're going to specify 3 question marks. And when our query will run, we'll substitute these question marks, these placeholders, with real values from our product to insert. I need to move the closing bracket so that the function will work. Let's run the script, and we can see that select all also been triggered, and it returned all products that we have currently in our table. So now that we have populated our table, we have some data to work with. But let's comment the execute many out so that the insertion wouldn't happen every time we run something else. Let's try another select statement, but this time, instead of selecting everything, we'll select just the suppliers. So we type select supplier from products. Again, we need to provide a cursor fetch all method within the print if we want to see the result in the console. And as you can see, we have 3 suppliers. Apart from that, we can perform the selection with some condition. For example, we can type select all from the table products, but with the price per ton. So we write where price per ton, and we put a placeholder there. And above that line, we specify the price. Let's say it's going to be equal to 12,000 money, and we put this price to the query. Let me copy another print statement and run the script and see what we'll get. And basically that will be just the avocados, because this is the only fruit that we have with the price 12,000 per ton, but we can also use less than or greater than as well. Other than selecting and inserting something into our table, we can also update the records in our table with the SQL query that starts with update. Then, of course, we provide the name of our table products and then the keyword set. So we want to set a supplier with a value of United Fruits, but we don't want to set any supplier, or otherwise we'll set all of them to be equal to United Fruits. So we need to provide a condition where price per ton and placeholder again. And here we provide the value for our condition. We'll call it United Fruit Price, and it will be equal to, let's say, 7,000. And we put it here into the query. I'll copy the print statement, but it is not necessary for the update clause. I'll show you why in a second. Don't forget the quotes around United Fruits because it's 2 words. And as you can see, we have nothing returned because the update query doesn't really return anything. It just updates the value inside the table, so in place. Basically, to see the changes, we'll need to read the data from the table again. So we perform the select supplier query, and as you can see, the first value is United Fruits, where United Bananas used to be. And the last CRUD operation, which letter D stands for, is of course the delete. And again, we don't want to delete everything, otherwise we could have just dropped the table. So we type delete from products, and then we'll impose a condition. So we type where, and here the condition will be the product ID to be equal to a certain value. Let's say we want to get rid of tomatoes, and so the product ID will be equal to 3. So we run the code, and we'll need another select statement. And let's say this time we'll use select all. We place it just below our last query, and if we run the code again, we'll see that we only have 2 records now. So the bananas and avocados, tomatoes are gone. So this was a crash course on interaction with the SQLite database using SQL queries. Next time, we'll study the ORM called SQLAlchemy, which you have probably heard of. Ave Coders, and welcome to the crash course on SQLAlchemy, where we'll learn the basic CRUD operations and how to interact via this ORM with the SQLite database. Long story short, SQLAlchemy will allow us to use Python functions on objects rather than writing SQL. So let's begin by creating a Python file where we're going to write our code. I'll call it SQLAlchemy example.py, and I'll just remind you that we're working from within the virtual environment. You can find the link in description on how to install and activate the virtual environment. If you don't have SQLAlchemy already installed, you can install it via the pip package manager. Just type pip install SQLAlchemy in the console and it will do the rest for you. And now that you have it installed, it is time to import the SQLAlchemy library at the top of the file and use db as its alias. And the first thing to do after we've imported the library is to create the engine. In simple words, the engine is the starting point for any SQLAlchemy application. And since we're going to be using SQLite database, please pay attention. There are 3 forward slashes. This is how we specify them within the create engine function. And in return, the create engine function produces an engine object based on our URL. But create engine does not establish a connection, so we'll need to call the connect method on the engine object, and we'll save it in connection. The next important concept of SQLAlchemy ORM is the concept of the metadata. In short, metadata is a container object that keeps together and describes many different features of a database or multiple databases. For example, the metadata object will contain all of the schema constructs we've associated with it. You'll see it taking its place in practice when we're going to be defining the schema for our table. So for this training example, let's create a table for a fruit company. We are pretty much capitalizing on the previous lesson on SQLite, where we're writing the actual SQL queries, but this time we're going to be using SQLAlchemy and its methods. So we're using the method table to create our table products, where we're going to have just 3 records for now. So we're going to specify the metadata as the next parameter, and then we're going to specify which schema our records will obey. So again, in this case, we're only going to have 3 columns. So on the new line, without any SQL, we write db.column and we specify our first column, which is going to be product ID, and it's going to be our primary key of type integer. So in essence, this is our 0th column, if you'd like, so we don't count it as the real column. However, it is real, but it will be handled automatically. That's why. So the first column we'll actually need to specify the values for or insert the values is going to be the product name of type text. The second one is the supplier name, which is going to be of type text as well. And the last column will be the price per ton, which is going to be of type integer. And now that the schema for our table is fully defined, we're going to call the createAll method on the metadata, and we'll pass the engine to this method. So I've noticed a tiny inconsistency. So the table name should not begin with a capital letter. Let me correct that. And then if I'll run the script by typing in the console Python, then the name of our file, SQLAlchemy example.py. And after pressing enter, you'll notice a new file in your working directory, which is of course our products SQLAlchemy database. And now that we've created our database and specified the schema for our table, let's populate our table with values or records. So we begin by specifying the insertion query where it all will happen. We'll take our products object and the insert method. Then we'll chain another function to it called values. And inside of that function, we'll specify our values, which will take a list of dictionaries where the keys are going to be the column names and the values are going to be, well, values we want to insert into our table. So for the first record, the product name will be specified as bananas. The supplier will be, of course, United Bananas. And price per ton will be 7,000 of money. The next record will have product name as Avocados, the supplier name as United Avocados, and the price per ton will be 12,000 of money. And the very last record will be tomatoes, with the supplier name of United Tomatoes and price per ton 3,100 money. Now that we've defined our insertion query object, let's actually insert these records into our table. And we can do so with the help of the method called execute. I will immediately comment it out because we don't want the insertion to happen every time when we run this code. And now let's actually check the records in our table, and we can do that, of course, with the select query. So we use the select method and we pass there the name of our object products. But bear in mind, because we expect multiple records back, we put it in square brackets. Once the selection query is ready, we can write a method to execute this select all query. So we use connection, execute, and we pass select all query. Then we print select all results. We use another method called fetch all to make sure it will return all of the results. And once we run the code in the console, we should see the 3 records we put into our table earlier on. So basically, if we'll leave the select without any other attributes or methods, it will return the equivalent of the select all query. But if we need to select the records by the specific attribute, we need to specify the condition using where clause, where we specify what is the column or attribute we're going to be looking for and the condition. So in our case, this is the price per ton. That needs to be equal to 12,000 money. And because under this condition, the only price per ton which is equal to 12,000 is the price per ton for avocados, we will expect to see just one record, which is going to be the avocado. But bear in mind that not only you can use the equality, you can also use greater than or less than, for example. So this was the operation of selection. But if we need to update the records in our table, we can use update method. In this case, we're going to be updating a single record. Therefore, we specify products, the name of our table, without square brackets. Then we specify the condition, again, where the supplier name will be equal to United Bananas. And let's say we want to change the value to United Fruits. And once we've finished writing our update query, we'll need to pass this query into the execute function. And bear in mind that because the update operation does not output anything into the console by itself, we'll need to use another select statement to inspect our table and see the changes. We'll comment out the previous print statements, and once we'll run this code, we'll see that the supplier name, the United Bananas, was changed to United Fruits. So now in the console, you can observe the impact of our latest update query. Let's comment it out, and let's move on to the last CRUD operation, which represents D, and this stands for deletion. Let's imagine that for this example, we will be dealing with tomatoes no more. Therefore, we need to remove the record from our table. Syntactically, deletion is quite similar to the update method. We specify the condition that will help us to allocate the record which we are going to delete, and this can be done in different ways. For example, we could have used the product ID, but in this case, I'm going to be using the supplier name, United Tomatoes. And similar to the update operation, once we've executed this code, we won't see anything in the console. Therefore, we copy and paste another select query. And as you'll see, now we only have two records. The tomatoes were deleted.
Ave Coders. In this video, we'll talk about the unit tests. So the very basic mechanism of testing your code. Well, after the print statements, of course. In general, unit tests make evident that even the smallest parts of your code work as they should. And this is why they're called unit tests. So why do we need them in the first place? Well, the fact that program currently works as it should is not really a good indicator that it will always work as it should, because at some point we'll want to add new features, new users, new edge cases, and so on. So when our program will start to become more complex, a little edge case that went unchecked can potentially collapse the whole thing. Therefore, we need a statistical confirmation that all parts of our code deliver the expected result. There is even a whole concept or software development process called TDD, for test-driven development. In short, it implies that you don't write a piece of production code unless you wrote a test for the case that this code would satisfy. So first you write the test, and then you write the code that will pass this test. I know it sounds a bit backwards, but once you'll get used to this philosophy, it will be hard to imagine how you would do things differently. I think I'll do a separate video on TDD, but in this tutorial, I'll introduce you to a unit test module that was created specifically for writing unit tests in Python. And I'll introduce you to the fact that you shouldn't be really afraid to write tests, and that it should be your pretty much basic habit.
All right, so let's jump straight into code. And for this tutorial, I'm going to be using a very famous example, which is a basic calculator. So inside of our file, basiccalculator.py, I will import math that we'll need to use later, and I will implement a few basic functions that will be addition, subtraction, then multiplication, division, and also raising to power, and the square root. So the addition, subtraction, and multiplication are pretty straightforward functions, but division will raise a value error when we'll try to divide by 0. Same goes with the power function. We are artificially limiting our calculator so it wouldn't be able to deal with the negative powers, and same goes with the square root, where we say that the argument of that function must not be a negative number. So for these three functions, not only we need to make sure that we are getting the correct result, we also would need to make sure they raise a value error in cases when they're supposed to do so. We'll put our tests in a separate file, which we'll call testcalculator.py, where we'll import the unit test module. And also we need to import our basic calculator so we can assess its functions. Once we've done that, we will define a class. We'll call it test calculator, and it needs to be inheriting from the unit test.test case. That way, Python will actually know that the methods we'll define inside of this class are actually test cases, not some regular methods. So this is what it basically looks like. This is the documentation, and as you can see, we have a bunch of methods, and then we use the assertion methods provided by the unit test module to make sure that whatever function returns is actually what is expected. So there are methods such as, for example, assert equal that compares what function returns with what is expected, and assert true, for example, whether a function is returning a true value, or assert false, and a bunch of others. I highly recommend to browse through the official docs to see what tools are available to us. But let's start with testing the addition function. So it is really important to write test at the beginning in the name, and inside of this method, we can use the assert equal method to check whether, say, for example, we add two numbers, 2 and 2, and the expected result is, of course, 4. So if everything is correct and the function works as it should, we will get a pass. So we'll get a successful test. Now, if we'll launch this code from our IDE, nothing will happen. So how do you execute a test? Well, there are a couple of ways around that. For example, first is via the console. So we write Python or Python 3, whatever your case is, then -m for module, then the module name unit test, and the name of the file, testcalculator.py. Once we'll run this script, we'll see the output in the console. So we run one test in 0 seconds, and the result is okay. And you can also see a dot above that dashed line. So the function ran as it should and returned the expected result. But if we don't feel like running the test from the console every time, we can write the following: if name equals main, and then we run main. For those of you who are puzzled what this is, I would highly recommend to check my video solely on the topic of if name equals main. So just follow the link. But now this if name equals main and then unit test.main will allow us to launch our test straight from our IDEs, like so. We didn't change anything else, so as expected, the result will be okay. And I'm literally going to show you what happens when you don't follow the convention of naming tests with this test prefix, so test underscore and then whatever your method name is or test name is. I'll remove them and we'll launch the code. Rather, I'll swap them around, so now it's addition underscore test, and when we'll launch it, we'll see that it is okay, but we run 0 tests. So Python couldn't recognize which actually method is the test. So this proves that following the naming convention is really important in this case. So let me change this back to where it was. So test underscore addition. And now let's check out how the test fail looks like. I'm going to change 4 to, let's say, 5. Therefore, function returns 4 and we have 5. They're not equal. So we are getting the assertion error, which says 4 is not equal to 5. Also, we have F above the dashed line, And the general verdict is that our test failed. And we have a number of failures, which is currently equal to 1. So really, you shouldn't be afraid to see your test failing. Let me reverse it back to what it was, and let's write a few more assertion statements. Theoretically, we can write thousands of assertion statements covering every possible case, but first of all, there is no point in doing so. And second of all, in this tutorial, I'm showing you the basic mechanics of unit tests. So second case is adding a negative and positive numbers. So -2 and 2 will give us 0. And the third one is summing up two negative numbers. So -2 plus -2 will give us -4. And now we see that we have succeeded, but we only see that we run one test. This is because it doesn't matter how many assert, equal, or assertion statements we have within a test, it still counts as one. So let's say we'll have 3 assertion statements per method. And let's move on and implement the next one, which is the subtraction. So once again, I think 3 assertions will be enough. The first one is 2 positive numbers, so 2 minus 2 will give us 0. Next one is -2 and 2 will give us -4 because we have -2 and minus and then a positive number 2. And the last one is subtracting one negative number from the other, so -2, and -2 will give us 0. It doesn't work straight like in, say, math that you can perform on paper, because you have -2, then minus, and -2 again. And then you have multiplication, which is going to be, again, multiplying first 2 positive numbers. So 2 and 2 will give us 4. Then we'll have one negative number and one positive number. -2 and 2 will give us -4. And then 2 negative numbers. So -2 and 2 will give us a positive 4. The next function to test is responsible for the division. First case is dividing 2 positive numbers. So 2 and 2 will give us, of course, 1. Then another edge case is -2 and 2 will give us -1. And the last case is to make sure our basic calculator can also output a fractional value. So 0.5 is a result of dividing 1 by 2. The function also raises an error when we try to divide by 0, but we'll skip it for now. We'll implement 2 other functions, and then we'll come back and implement this exception thing. So the next one is the power. The first case will be raising 2 to the power of 2, which gives us 4. The next edge case is when you have a 0th power, so you're raising 2 to the power of 0, that will give you 1. And the last one is raising 0 to the power of 2, which will of course give us 0. Once again, we'll implement the exception later after we'll finish with the last function, which is the square root. So the square root of 4 is of course 2. The square root of 0 is 0. So I'll leave just 2 assertions here. You can write in the comments what other edge cases we could have implemented in this code. But first, let's run it and see if it works. Spoiler alert, it will work as it should. We'll see OK for all tests. We see 6 dots, which are representing roughly the number of tests. And we can see run 6 tests, and then how much time did it take us. Let's also check how it will look like when we have multiple tests and one of them fails. So let's say I'll change the first assertion in the subtraction test from 0 to 4. And when I will run the code, I'll see the failure, of course. We have 5 dots and then F. Also, we see the failures equals to 1, and then why it actually failed. So assertion error 0 is not equal to 4. So this is how it looks like. Let me reverse it back and we will get on with dealing with the exceptions. So just to remind you, back in the basic calculator.py, we have 3 functions, which is the division, power, and square root that raise value error. The division function does it in case of the division by 0. The power function is artificially limited to not have the negative powers, and square root function doesn't accept negative numbers. Therefore, we'll need to make sure that these 3 functions raise value error when they're supposed to raise it. And to accommodate this behavior, we will be using a different assertion method that is specifically designed for the exceptions to make sure the value error was raised, and this method is called assert raises. And as you can see, we apply it in the most Pythonic way, with the context manager. So if we'll try to perform the division by 0 and the exception is not thrown, then the test will be counted as failed. And if we'll run the code now, we still have 6 tests and the response is okay. Now let's implement similar assertion statements for our test power method, and is going to throw another exception there. And also for the square root, just checking that it runs and returns okay. And now we're implementing the last assert raises for the test square root with the value -2. And this concludes our introduction to the basic unit tests, the assertion statements, and how to write them. We run the code once again, we see OK, and we're happy.
Ave Coders, most of you have seen this construct. And in this video, I'll explain what it is, why we need it, and where it is best to use it.
First of all, what does name attribute means? Here I've imported 2 modules, math and pandas. It means that their attribute name will contain the name of the module as a string. So if I'll request the content of this attribute from the module math and module pandas, in the console I'll see 2 strings, math and pandas of course. This is also true for all modules that we create ourselves. Here in the file ave.py, I've defined a function, Ave. All this function does, it prints salutation, Ave, and also the content of the name attribute. And if later I'll import this module, I'll get access to the function of the module I've just created. Therefore, via the dot, I can get access to the content of the name attribute of this module, Ave. And also I can call the Ave function from the module Ave itself. In the console, we'll see that the content of the name attribute of the Ave module is indeed Ave. So this was the name attribute. Let's take a look at what does the main string means. In case we would not be importing our file, but rather launching it as a script from the console, for example, we'll get a slightly different result. The content of the name attribute will contain the string main. Here I've defined a new function called func. Next we print where we are, and then the content of the name attribute. Then we define a condition. If name, so the content of the attribute name, contains main, then we call the function func. Let's create another file, testmain.py, where we will import the test module we just created, where we also print the content of the name attribute of the imported module test module. And then via the dot operator, we call that func function from the test module. After launching this code in the console, we'll see that there was a call to the func function, but the name attribute from the test module contains the string test module. However, if we'll roll back to the test module.py and we'll launch it with our IDE, we can see that content of the name function is main. We can also do the same with the actual script. The point is that if we run this file as a script, its name attribute will inevitably contain the main string.
So what does this if name equals main means altogether? As we already know, the name attribute contains the name of the module when it is imported from another file. But when we launch the code from the command line, for example, then this attribute name contains the actual string main. And so this if name equals main can be translated as run the code after this condition only if we run the file directly, so from command line, for example. But if the file or the module is imported, then if name equals main and the code in this condition will not be triggered. So in which case can we utilize this construct? Let's imagine that we want to check some function's output result. So if we run this file, then the function will be executed according to the code after if name equals main. However, if the file was imported, then the code or the function will not be executed. Therefore, it allows us to execute it only when the file is run as script, not when it is imported as a module. And as a conclusion, in Python, you don't necessarily need to call your main function main. It is not as strict as it is, for example, in Java. Surely in large and complicated programs, the main function indeed can be called main, but in terms of the programming language mechanics, it doesn't have any extra privileges. Therefore, you can name your main function as you like.
Ave Coders, today I want to talk about the Python Zen or PEP20, which was created by Tim Peters in 2004, and it serves to inspire and guide Python coders to write beautiful code, ensuring code readability, which promotes code reusability. Not many people know, but you don't actually need to go online to read this guide. If you're using Jupyter like myself, you can actually open a blank document and type something like import this. And as you can see, this is the Python Zen. And I'm going to briefly explain you what each line means, and you can check out the example code in the Ave Coders GitHub repository. Number 1, beautiful is better than ugly. Beautiful code is achieved through a combination of explicit, simple, sparse, and flat attributes to help ensure a high level of readability. On the other hand, ugly code is hard to read, thus hindering the potential for code we use. The next one, explicit is better than implicit. Explicit, an attribute of beautiful code, offers a thorough, detailed illustration or explanation of what your program is doing, therefore making it more readable and easier to understand. Simple is better than complex. Simple is another attribute of beautiful code which provides clarity through uncluttered, straightforward code, which is easier to understand than complex code, and therefore it helps to be more readable. Complex is better than complicated, or sometimes referred to as complex is prettier than complicated code, but it's still not as desirable as simple. Some situations, however, may call for a complex solution, for example, to maintain sparseness if a simple approach cannot be found. So bear that in mind when writing your code. Check out this database example to see what I mean. Flat is better than nested. Of course, this choice of flat over nested depends on the situation. So with the occasion we are opting for flat means better readability and more efficiency and time in our memory, then this endpoint encourages you to opt for flat over nested. Sparse is better than dense. Sparse is the last attribute of beautiful code covered in PEP20, which encourages you using less line of code, since less, for example, less cluttered can help to achieve more readability. You can check out this code example where we pass an HTTP response object yielding back new requests or data. And I bet that the second option is much more pleasing to your eye rather than the first one. Besides, when someone just starts off writing code in Python, he or she normally writes code as it is written in the first option, because a beginner coder doesn't need to explain the code to anyone. Thus, this dense written function code can be met quite often among the junior developers. Well, let's move on. Readability counts. Writing a beautiful code by using a combination of the attributes I mentioned helps to ensure readable and maintainable code. As Guido and Rossum, creator of Python, put it, If code is not readable, it cannot be reusable. Special cases aren't special enough to break the rules, although practicality beats purity. So as an example, we are given the code where we tasked to write a function that returns another function, and also we need to test the floating point. So here, instead of the counter function, we are using the adder function with lambda. And as you can spot, one of the assert functions breaks the rule. So it's not special enough to break the rule of floating point, and we can actually do it differently. Next one is errors should never pass silently unless explicitly silenced. So Python has exceptionally easy ways of handling errors and fixing them on the fly, so we must use them. So here you can see, as an example, we have to import the JSON library, and in case we can't do it, we need to raise an exception. The next one, in the face of ambiguity, refuse the temptation to guess. This is a short and easy rule to follow, meaning that you should look up how to do something rather than guessing how to do it. The next one is there should be one and preferably only one way to do it, although that way may not be obvious at first unless you're Dutch. So the first one is easy, you just pick the best option to do things. And the second one is a sort of a joke. It refers to the Guido van Rossum, who is Dutch. May not be obvious at first, means that you can always find a way to do something, but the first thing you think of probably won't be the most efficient. Now is better than never, and although never is often better than right now, means that when presented with a problem, don't spend too much time figuring out the perfect way to solve it. Code something that works, then refactor that code. For example, write a test and write the code that passes that test, and then improve that code. Although you have to be careful, because it is important to give some thought into the problem before you start to solve it. Make sure that the code you're writing is actually working. And this is the approach used in something called test-driven development, or TDD. But we'll move on to the next one. If the implementation is hard to explain, it is a bad idea. And equally, if the implementation is easy to explain, it may be a good idea. The basic principle is, if it's hard to explain, then it's too complex and complicated and therefore hard to read and understand. Thing is, if you finally figure out and understand the implementation, the likelihood you'll remember in the future is low. But if you have an implementation that is easy to explain, it may be a good idea. However, just because it's easy to explain doesn't mean it's the best solution. So make sure it is the best solution before you go and implement it as your permanent solution. And so we approach the very last statement. Namespaces are one honking great idea. Let's do more of those. This last statement encourages us to optimize the use of namespaces in our Python code. So namespaces are typically employed for the purpose of grouping symbols and identifiers around a particular functionality. This helps to create a higher level of organization while promoting readability and the potential for reusability. Ave Coders, in this video we're going to be solving the palindrome challenge. Now this challenge is very popular, so you might encounter it in your technical interview for junior software engineer position. But before we begin, let's remind ourselves what is a palindrome. So a palindrome is a word, phrase or sequence that reads the same backwards as forwards. So palindromes might be short or long, consisting of a single or multiple words. Short palindromes such as Madam, Nurses Run, Civic, Radar, Level, or longer palindromes, Mr. Owl ate my mental worm, was it a car or a cat I saw, and never, odd or even. Now that we know what palindrome is, let's take a look at the challenge itself. So we need to write a function that defines whether a given word or phrase is a palindrome. So we're going to have a string to evaluate as the input, and as the output we're going to produce the Boolean value true for a palindrome and false for a non-palindrome string. There are several conditions which we'll only consider letters from A to Z and we'll ignore their case. So for us, capital Z and non-capital Z will be the same. Here's an example. Is palindrome is a function. It takes Ave Coder as an input and it produces false because Ave Coder as a string is not a palindrome indeed. And this is the same function but with a well-known palindrome, Madam I'm Adam, and it produces true because it is a palindrome. Try to solve it by yourself first and I'll see you on the other side. For this challenge, I'm going to be using the Jupyter Notebook. First of all, I'll rename the notebook and I'll need to import the regexes. So I'm writing import RE. And down below, I can define my function is a palindrome. So I'll add a new line and in here I'm writing def for function is palindrome. And inside the brackets, I'll specify the parameter that is a word, which is going to be expected by the function, and we're going to pass a string. Variable forwards will contain the result of us passing from left to right, and we're stripping our string, and therefore we'll join them together as just the characters, ignoring all apostrophes, commas, and spaces, and we're utilizing the function findAll, which is a function from the standard regex library. And here we're passing the pattern that we'll be looking to match. And we're going to utilize a lower function on the word input so that we'll make sure that all characters in the input string are lowercase. Next, I'll declare a variable called backwards, which will store the result of a backward pass, which is essentially the same as the string stored in forwards, but this time we pass -1 to read it backwards. And now the only thing left to do is to compare the two, so forwards and backwards. And obviously if they match, it will return true. If they don't, it will return false. So this is one of the possible implementation. There could be many others, but now let's test the function by calling it with a string Ave Coder, and of course make sure that the string is within the quotes and it returns false because Ave Coder is indeed not a palindrome. Let's pass a well-known palindrome, Madam I'm Adam, and that should return true. Let's run it, and that returns true. Right, I hope that helped. Try to write your own implementation for this popular challenge. Ave Coders, in this video we're going to be solving a very simple yet very popular challenge called sort the string. So we need to write a function to sort the words in a string. As an input, this function will receive a string full of words, of course, and as the output, we're going to need to output that same string of words sorted alphabetically. However, there are a few conditions, such as we should ignore the case. In this example, the is equal to the. It doesn't matter if it's written all caps or not. But we must preserve the case as well. So let's have a look at the examples. Here are functions sort words. We have three words: naming, talking, and shouting. Naming begins with capital letter, shouting all caps. And here we have an output. All words in a string sorted alphabetically, but they still have this capital letter for naming and all caps for shouting. Pause the video here and give it a try. Alright, so I'm going to be using Google Colab, and here right at the top you can see the 4 lines of how I'm going to solved the challenge. So the permutations, if you'd like, that illustrate that I will take these words and I'll prepend them with their doubles, but in the lower register, and then I'll sort them and I'll throw these prepended doubles away. That way we'll be left with the original set of words, but this time they will be sorted alphabetically. And this will also allow us to preserve the case. Alright, here I'll declare my function and I'll call it sort words. And here's the input, so the string we're going to be passing. And inside the function, I'm going to declare variable words that will hold the result of the split. In other words, we're going to split this string, in this case by the space, but you can do that by any other delimiter like comma. On the line below, I am prepending the words in a string that now been splitted with their lowercase double. And after we've done that, we can actually do some sorting. So I'm going to use the sort function. All right, and now that they are sorted alphabetically, we can actually get rid of this lowercase double. And the only thing that will be left to do after that is to return that string. But right now, I've made a split by the space. I should have done it with the comma, but nonetheless, I will use the join operator to put these words back into a string together. So I'll join them together into a string. However, this illustrates the idea. So let's call the function with probably the same set of words, the same string that we have on the top. So naming, talking and shouting. And if we've done everything correctly, we're going to have pretty much the naming, shouting and talking. Pretty much the expected result, but as I've said, I should have used the comma as a separator, but I've noticed this only after I've recorded the video. Ave Coders, in this video we're going to be solving the prime factors challenge. But first of all, what prime factors are? Prime factors are factors of a number that are themselves prime numbers. In other words, any of the prime numbers that can be multiplied to give the original number. This is a marvelous definition, but what is a prime number then? Well, the prime number is a number that is divisible only by itself and 1. For example, 2, 3, 5, 7, and 11. For example, let's take a number 180. So its prime factors are 2, 2, 3, 3, and 5. So if we'll take these numbers 2, 2, 3, and 5 and multiply them, we're going to get 180. However, this is not the case with numbers like 13 or 17 because they are the prime factors of themselves. Alright, so this is a challenge. We're going to write a function to find all prime factors. So as an input, we're going to get the integer value, and the output, we're going to output the list of prime factors. Let's take a look at the example. For example, we have the function called prime factors, and we pass 180 into the function, and we get a list of these prime factors: 2, 2, 3, 3, 5. Pause the video here, try to solve it yourself, and I'll see you soon with the solution. For this example, I'm going to use Google Colab. We don't need to import anything, so we can use the plain Python. So let's get on with the function then. So I'll call it get prime factors, and it's going to have parameter n, which is going to represent all the integer values that we're going to input into the function. And here we declare the factors variable that will store the list of our prime factors. And this variable divisor will hold a value for our divisor. So we're going to start with the 2, and we're going to divide our number iteratively by 2. So I'm going to use the while loop here. So while the divisor is less than or equal to the number, I'm going to divide the number on this divisor, and if the divisor divides it with some remainder, we're going to increase the divisor by 1. So in other words, if n mod divisor equals to 0, then we're going to append this divisor to our list, and we're going to iteratively store the value after the division into the number. Otherwise we'll divide the same number again and again. And in any other cases, we're going to increment our divisor by 1. And our function will return the list of prime factors. So return factors. Alright, so the function is ready. Let's test it. So down below, I'll call the function with a number. Say the argument will be equal to something from the examples. I'll take 180. So 180, get prime factors, and we get the list of 2, 2, 3, 3, and 5, same as in example. But if I'll change it to say 13, then we're going to get just the number 13. And the same goes for 17. We're going to get 17. That's it. So this is one of the possible solutions for these challenges. So keep solving challenges, keep coding, and everything will be fine. Ave Coders, and welcome to the Unique Words Challenge. So we need to write a Python function to count unique words and number of their occurrence in the text. So as the input, our function will receive a path to the text file or the text file itself, and output is going to be total number of words, top 20 most frequent words, and number of occurrences for the top 20 of these words. In other words, how many times those top 20 words occurred in the text. So let's briefly have a look at the example. So here we'll have our function called something like count words that will receive a path to the file shakespeare.txt, and here are the top 20 words in this file, together with the number of how many times these words occurred in the text. Right, so try to solve it yourself, and later on I'll show you my solution. It might not be the best one, but it does the job. But before I'll do that, I can hear your question, where can I take this file from? Well, use your own text file, or alternatively go to the shakespeare.mit.edu where you can get those pieces written by Shakespeare. So, good luck. Alright, so here is my solution. I've decided I'm going to use the Google Colab because here we can upload our file shakespeare.txt from my local drive. The only thing to remember, and Colab will remind us, is that if we'll restart the runtime, everything will be lost. Alright, so, and once it will appear on the left side of the Colab, I can collapse that part and start working on our function. Right, first of all, we'll need to import the regular expressions or the regex module, import RE, and as well we'll need to import the counter from the collections module. And once we are done with that, we can get on with the function. So I will define it as aforementioned count words function, and it will receive path as the input. So as you might guess, path will represent the path to the actual file. And we're going to use the context manager to open the file. The encoding going to be UTF-8, of course. So next what we need to do is we need to find all words within the text, and I'm going to use the regular expressions for that. So the pattern itself will look for any number of letters, numbers, hyphens, or apostrophes. So I convey the information I need to search for in the file with this sort of pattern. And once we've done that, we need to convert all words we find in the file into the uppercase. And once again, I'll store the result in the all words. And finally, we'll print the length of this list, which indicates the number of words that was found. Next, we'll create a new counter object. And then using the for loop, we're gonna iterate through the list of all words and increment our counter anytime we meet a unique word. And finally, we're going to print the top 20 words that occurred in the text together with the number of times they have occurred in the text. And I'm going to use the most common method to do that. All right, and now that we're ready, we can call the function, so count words, and I'll pass the SQLAlchemy, which I store in my callup. So in my case, I don't need to provide the path because my path is just the name of the file. It sees it locally, but I forgot the single quotes. All right, so here we can see the total number of words in the file SQLAlchemy, along with the top 20 words and the number of times they occur in the text. Ave Coders, in this video we're going to be solving another popular challenge, which is sometimes called the waiting game, but I think we are not waiting for anything, we're trying to be on time. Therefore, it is an on-time game. Alright, so what is the point of on-time game? So we're given a target, for example 6 seconds, and first we press enter and the timer starts. Then we press enter again and the timer stops. And then we're shown the results, whether we've been on time or not. So we display introduction to the user, then we tell them how many seconds they need to wait before pressing the enter key. Then we calculate the difference and we tell them how well they did. Now let's have a look at the example. So for example, we have a target time, which is say 6 seconds. And we tell them, please press enter to begin. And we need to press enter again at 6 seconds. And then we display the elapsed time. And in this case, the user was too slow. Otherwise, it might be too fast or on time. Try to implement it and I'll see you on the other side. Alright, so I'm going to be using Google Colab, and first I need to do a couple of imports. We need to import the time because we're going to be using the counter, and a random for pseudo-random generation of the integer that's going to represent the target time. Alright, now that's done and we can get on with our function. So I'll call the function onTimeGame and it will have no parameters. And first of all, we need to define what the target time is. So I'm going to declare a variable called target, and it's going to be equal to random, and I'm going to use random int because I want the whole number. So in this case, the number will be more than or equal to 2 and less than or equal to 4. All right. Now we're going to pass that value of the target variable into the print statement. So we're going to say something like your target time is, and here we're going to pass the target via the format. So dot format, and here we are passing the target. Next, we need to interact with the user somehow. So I'm going to take the user's input. I'm going to use the input function for that. So input, press enter to begin. We'll make it nice and pretty. And next we need to start the counter. So I'm going to declare a variable called start, and it's going to be equal to, and I'm going to use the function from the time module perf counter. So that will kick in the counter, and now another input, something like press enter key again to stop the counter. So I'll say press enter again after, and then we're going to give the target here as well. Just as a reminder, so maybe the user forgot about it. So target. All right. I'm going to utilize a simple logic to calculate the elapsed time, so how much time effectively passed since the user has pressed the enter key once. In order to do that, I'm going to use this perf counter construction again, and I'll deduct the start variable from it. If you're asking yourself why cannot we deduct start from the start, well, give it a try and have a look what comes out. Now another message, this time we need to tell the user how much time has passed, so the elapsed time. And we're going to format it so we have 3 digits after the dot, and it's going to be a floating point, of course. That's going to be seconds, and we're going to format, and in here we're going to pass the elapsed time, so the variable elapsed. When that's done, let's perform a simple check whether the user was on time or not. So that's an if statement. So if elapsed was equal to target, then we print that, good job, all that. So but rather I'm going to print formally on time. You are on time. Elif, so else if, well, effectively in other case we say if elapsed time was less than target, we print that the user was too fast, and we need to give a value. In other words, we need to tell the user the difference between the target and the elapsed time, and this time we need to deduct the target, the elapsed time from the target that way, so we can pass the expression into the format. And else, one last condition, if the elapsed time was greater than target, we're going to print something like that the user was too slow, so he or she was waiting for too long, and in order to give the estimation we'll need to deduct elapsed target from the elapsed, so other way around, and we can do that inside the format, so elapsed minus target. Now let's give it a try and we'll see if all conditions work. So I'm going to call that function. Of course I cannot guarantee that I will be on time. I can guarantee that I'll be either too slow or too fast, but anyway, let's give it a try. So press enter to begin. 2 seconds. Well, I was too fast. So this condition works. Let's try another situation. So press enter, 3 seconds, and I was too fast again. So let me try to be too slow. Press enter, 2 seconds, waiting, and we are having an error. So there must be a typo in float point representation. Yes, so I forgot a colon here. Let's give it a try one more time. Press enter to begin. Sure. Press enter 4 seconds. Sure. I'm too slow. Everything works as it should. Alright, so that was one of the possible solutions to this challenge, and I'll encourage you to try to find your own. Ave Coders, in this video we're going to be calculating the probability of certain outcomes when rolling dice. And in order to do this, we're going to be utilizing the Monte Carlo simulation that uses random sampling to evaluate possible outcomes. So the challenge for today is to write a Python function to determine the probability of certain outcomes when rolling dice. What we're going to get as the input is the variable number of arguments for sides of dice. And this function needs to return a table of probability for each possible outcome. There are several conditions or caveats, if you'd like. First of all, we might use several dice, so the function needs to account that possibility, and the number of sides per dice may vary. And to exclude any possibility to hard code anything, we're gonna set the attempts to 1,000,000 tries. Let's have a look at the examples. So for example, we have our function, we'll call it, say, roll dice, and we pass the number of sides for a die. So we have one 6-sided die. And the function returns the probability for each side of the die. Equally works for two 6-sided die, but here we get the probability of the sums. In other words, what's the probability of throwing 7, 11, 3, and so on and so forth. Pause the video here and try to solve it yourself, and I'll see you on the other side with my solution. All right, here we go. So I'm going to use Google Colab, and what I'm going to do first, I will import the random or pseudo-random from the random module. So I'll import rand_int because I'm only interested in the whole numbers. After that, from collections, I will import the counter. We'll utilize it to count the number of tries. Now that all imports are done, we can get on with our own function. So I'll call it, as in example, roll dice, and I'll prepend the function parameter with an asterisk, which means we're going to pass a variable number of arguments to that function. And the second parameter is going to be num_trials, which we will hard code to 1,000,000. Pay attention that we can actually use underscores with the number to divide it, and Python will have no problem with that. Next, we'll initialize variable count, which will contain our counter. And after that, we can specify the for loop. So the upper bound of this for loop is going to be our num_trials, which is 1,000,000. And as long as it's not reached, we're going to perform the following. In essence, we are simulating rolling each of the dice in a variable input parameter and some individual outcomes together. And we can also use the resulting value as the index into the counts dictionary to increment it by 1. And what is left to do is print them out. So we can use the for loop to print out the distribution of individual probabilities as the percentage value. All right, let's give it a try. I'll call this function with, say, one 6-sided die, and we're going to get the distribution of probabilities. So here we go. Works as in the example. So let's try with several dice. So a couple, 2, 6 and 6, and we get the probability distribution of sums. Ave Coders, in this Python challenge, we're going to be solving the Sudoku puzzle. So here it is. Write a Python function to solve a Sudoku. So I'll remind you how Sudoku looks like. So we need to fill a 9x9 grid with numbers so that each row and each column will contain all numbers from 1 to 9. And the condition must be true for this 3x3 block of cells as well. So usually we start with the partially filled grid, and we need to fill the gaps so that it will be complete. So this is how the solved Sudoku looks like, and effectively there is only one solution. In other words, a unique combination of numbers that satisfy the constraints. And this is how we're going to pass the puzzle into the function. So where the empty cell is in the Sudoku puzzle, we're going to have 0. So this is a 2-deal list. And what we need to do, we need to swap those zeros for numbers that satisfy the constraints of standard Sudoku puzzle. You can pause the video here and try to solve it yourself. Otherwise, stay tuned and I'll show you one of the solutions. Alright, so let's get on with the solution. This is going to be some sort of depth first search with backtracking. I'll be using VS Code, and first of all I want to import product from itertools. It computes the Cartesian product of input iterables, which is effectively equivalent to nested for loops. Okay, and after we finish with the input, we can start writing our function. First of all, we'll use this iterator to, well, iterate through all possible combinations of rows and columns. So effectively, we evaluate each position and we try to define whether it contains 0. In other words, is it an empty cell in which we can record some value to solve this puzzle or not? If it is, then we can slide into the for loop where we will be assigning this position a value between 1 to 9 until we won't get the right number. After that, we need to check whether this number already exists in the same row or in the same column, because remember that every row and column can contain only one instance of a number from 1 to 9. And if everything is okay with this condition, we check the same rule for a 3x3 box. If both conditions are satisfied, then it must be a legit number for this particular position, and we can place it there. Next, we call this function recursively, but with the renewed grid. So it takes into account the number that we already used to fill in the gap in the puzzle. And pay attention to this relatively new operator called the assignment expression that assigns values to variables as part of a larger expression. Also, it goes by the name Walrus operator. Lol. If our function was able to find a solution at this point, it will just return the solution. But if it got stuck and it has to effectively backtrack, then we declare the position equal to 0, and thus the loop will be able to carry on from the point when we found a last viable solution. However, if there will be no possible solution found at this level, then it will return false and we would have to backtrack to the level above. And finally, when the solution was found, the function returns the completed puzzle, which is effectively a to-do list. But of course, here we go an extra mile and we write another function that will print the solution to the screen. Alright, so that was one of the possible solutions. Please write in the comment if you know some more. That was V. Please give this video Emperor's thumbs up, toll the bell and subscribe.
If you're watching this, that means that you have enough patience and determination to become a Python developer and you're ready to hit your goal. Check the links in the description where I've left some useful resources where you can continue your journey. Good luck, you're doing really good.